morning, all the participants who are here on the virtual platform of National Webinar organized by Department of Agronomy, College of Agriculture, Navsari Agriculture University, Bharuch. On this third day of this webinar, today we have eminent speakers, especially Dr. Y.P. Singh sir, Dr. Anil Dixit sir, Dr. R.A. Jat, Dr. Tushar Patel, and Dr. N.N. Gudadhe. So each one are an eminent speaker having a very vast working knowledge or research experience in their special subjects. However, when we talk about the first eminent speaker on this auspicious occasion of this national webinar on the third day, I am highly enlightened in the gracious presence of the Dr. K.G. Patel, sir, Dean Faculty of Agriculture, to invite Dr. Yashpal Singh sir. Before inviting the Yashpal Singh sir, I am going through his biodata, brief biodata. That is Dr. Yashpal Singh sir, working as a principal scientist at ICR, Central Soil Salinity Research Institute, Regional Research Station, Lucknow, has been conferred with Fellow of ICR, National Academy of Agricultural Science, NAS, for the year 2020. Dr. Singh has developed low-cost technologies for sustainable reclamation of salt-affected soils in Uttar Pradesh. His land that included state-level package and practices facilitate to enhance crop productivity, rice and wheat in salt-affected soils. He has contributed in developing salt-tolerant varieties of rice, wheat and mustard, which are being adopted by a large number of resource-poor farmers having salt-affected soils. His innovative work on eco-friendly management of municipal solid waste for reclamation of sodic soil is highly appreciable. On the basis of his research contribution, International Rice Research Institute (IRI) has appointed him as consultant crop production for promoting rice cultivation in 6 East and Southern African countries, while Tanzania, Malawi, then Rwanda, Uganda and Kenya. His research work has recognized by ICR and bestowed him ICR very prestigious award, Hariom Ashram Trust Award for outstanding research in the field of natural resource management. The integrated farming system model developed for enhancing land and water productivity of waterlogged sodic soils is a milestone for doubling the farmer's income in stress-prone environment. Dr. Singh has published over 100 technical papers in leading journals and conference proceedings, edited 2 books, written 18 technical bulletin folders on reclamation and management of salt-affected soils and rice production agronomy, 15 popular articles and 10 book chapters. He is a member of various scientific societies and acting as a resource person for IRI national and international training. So today I'm very enlightened to invite Dr. Y.P. Singh sir. Please sir, now stage is yours sir. Dr. Y.P. Singh sir.
Hello sir.
Can
you hear me?
Yes, you are audible sir.
Thank you very much sir. Thank you. Yesterday I received the phone call from Dr. Patel sir, head of department. Sir, I'm still not feeling well. I'm having the fever and cold and cough. So even after that, I had to fulfill the commitment which I have made with you, sir. I'm not. So please bear with me.
Okay,
so I'll try my level best to convey my message, whatever I wanted to share with you with the speaker sir. So, respected Patel sir and distinguished scientists and the galaxy of the scientists present in participating in this webinar. Sir, I would like to share an innovative idea that you can say none of have done the work on the utilization of municipal solids waste for the reclamation and management of salt affected soils. So, sir, you are well aware that our institute, Central Soil Salinity Research Institute, had developed many more technologies, and among the first and foremost technology was the gypsum-based technology. And but slowly that many more technology, utilization of organic waste in combination with the gypsum was also tested. And in that, among that, the organic source of amendments were be tested at our institute level, were the you can say the FYM and then gypsum and etc. So now you can see nowadays the availability of FYM itself is becoming a problem, not available in abundant quantities. Similarly, the fresh mud, earlier it was used for the reclamation and salt affected soils, but nowadays slowly it's utilizing for brick kiln industries. So that is not available in abundant quantities. And another third, the chemical amelioration, that is input is the gypsum, which is the main important input for reclamation of salt affected soils. So nowadays the environmentalists, they are the major source of gypsum was from Rajasthan mines. So now the environmentalists, they are also creating problem, and that gypsum is not available in the abundant quantities. And you are well aware that in our country there is about 6.7 million hectare salt affected soils. Next slide. So so that's why that now you are well aware that the municipal solid waste, which is available in abundant quantities in our country, and in most of these cities, they are producing large quantity of this municipal solid waste. And then the government is facing problem for the dumping of that dumping and management, you can say, of that municipal solid waste is becoming a problem day by day. So that in most of the cities, the government is trying to level best that they are certain treatment, municipal solid waste treatment plants are government is initiating to utilize that for energy production as well as for composting purposes, that municipal solid waste. But it's still that large quantities of you can see, if you go to Delhi, you will find a large dump heap of that municipal solid waste. So sometimes some incidents may also happen because of that dumping. So still there is a problem of that municipal solid waste. So how best we can utilize that municipal solid waste? So this project was conceptualized by me, and the government of Uttar Pradesh has funded that project. How best you can utilize that municipal solid waste for reclamation of salt affected soil. In Uttar Pradesh, you are very well aware that there is 1.37 million hectares salt affected soil in Uttar Pradesh. So that's why I initiate the work on management of salt affected soil with the use of municipal solid waste compost. So, and the available compost which the industries are producing, our nearest municipal solid waste treatment plant is in Lucknow as well as in Kanpur and most of the cities, and they are producing the compost. But the cost of that compost, even that compost, is very high. They are about 5 rupees kg or 10 rupees kg, or somewhere it is at 25 rupees kg per kg municipal solid waste compost they are selling to the selling in the market. So how we can minimize the cost of production of that municipal solid waste? That is also important part of my study. So I'll share that, sir. So next slide, my challenges facing Indian agriculture. Everybody knows this is not a new thing. Most of the presenters, they have already earlier presented this slide, that the degradation of the soil health, and then imbalanced use of fertilizer. This is another major challenge for our Indian agriculture. Emerging multi-nutrient deficiencies, particularly in secondary and micronutrients. Slowly, earlier there were only NPK, and then sulfur and magnesium and copper, and so slowly then several micronutrient deficiencies are emerging in our agriculture. And then declining the factor productivity. This is another important reason behind the agriculture our facing. and then slow growth in food productivity, and then climate change is nowadays is a burning issue. So everybody is talking about climate change, climate change. So this is another reason for a challenge for our agriculture, Indian agriculture. And now the factor, the influencing the soil health. Soil health is another important factor for the agriculture challenge in agriculture. The soil health, these are the certain factors, you know, that soil moisture, soil temperature, soil pH, soil organic matter, and then nutrients, and then beneficial microorganisms. These are the certain factors which plays an important role in the maintaining the soil health. And now how we can manage the soil health. So there are certain issues related to soil health, and then these are the strategies how we can manage that soil health. So the issues are the declining level of soil organic matter. Well, this is an important issue nowadays, and this is the challenge for our scientists, that how we can maintain the soil organic matter status of our soil. So that the strategy that we have to manage organic matter, that we should prepare some strategy. And then widening NPK ratio. You know that, sir, nowadays, even today, we have the NPK ratio 4:2:1. Our worthy Honorable DDG Saab has given this, raised this point in his deliberation, in his inaugural address. That so we have to think over that how we can minimize the dependence on nitrogen. This ratio, how we can, this 4:2:1, how we can minimum the use of nitrogenous fertilizer and maintain the balance. And then micronutrient deficiencies, this is another important, the micronutrient. So for that we have to prepare the strategy for diversify the soil biota. And then declining response in terms of grains per kg fertilizer, or you can say fertilizer use efficiency is declining. And then to maintain that to fertilizer use efficiency, we have to maintain the soil cover, and or you can say the conservation agriculture is another strategy for increasing the fertilizer use efficiency. And then heavy metal pollution. This is another issue of heavy metal pollution, and for soil health management. And then for that we have to prepare the strategy, change our crop rotation, or include the pulses and pulses crops in our or cotyledon crops in our crop rotation, so we can maintain that soil health. And then low nutrient use efficiencies. So for that we have to, I have already explained earlier, that the balance use and improved fertilizer application. And then land degradation is another issue, so we have to use the organic amendments. Now the soil health management planning process, what the government or what we are doing, that for what is our process to managing the soil health management. So first of all is the farm background to manage our soil health management. So we have to have farm background and management history, and then set goals and samples for soil health. And then constraints identified. We have to identify the constraints and then explain that constraint, and then prioritize those constraints. And then identify feasible management options and create short and long-term management options, and implement, monitor, and adapt those management options to maintain the soil health. So next, now come to salt affected soil. Come to my major topic, major point of that. The salt affected soil, this is not a new thing, sir. You know, you are very well aware that the salt affected soil in our country is 6.73 million hectare, and out of that 3.77 million hectare is sodic soil, and 2.96 million hectare is sodic soil. So we have to, and now you see that our population, to feed our population, we have to manage these degraded lands, because day by day our cultivated land is reducing, or you can say the per capita cultivated land is reducing day by day because of the urbanization or industrialization. So how we can manage the food for our increasing population? So we have to focus on management and put those unproductive agricultural land to productive use, and the salt affected soil is one of them. How we can manage those soil, or how we can make those soil productive. So this is you can see the peculiar characteristics of the sodic soil. If you see the peculiar characteristics of the sodic soil, sorry sir, this is the sodic soil. One photograph, when these soils, there are another photograph in that left side. When you are in summer season, you will find these soils are completely a powder, white powder. This photograph, I don't know why this photograph is not coming. But when it is, when after rainy season, when it is dry, you can see the crack. This is completely cracked. This is the peculiar characteristics of the sodic soil. And these are having poor physical properties due to high sodicity and high pH and low infiltration rate. And the soluble salts contain predominance of sodium carbonate and bicarbonate. And these soils are deficient. The major problem is that these soils are deficient in organic matter and available nitrogen, calcium, and zinc. So these are the certain parameters on which we can say that these soils are very poor in organic matter. If you are able to increase the organic matter content of in these soils, they can reclaim, or you can manage these soils very well with the addition of organic matter. So you see the state-wise share of salt affected soil in India, and the Uttar Pradesh is having this maximum share of salt affected soil in the country, and out of this Gujarat 14.3% sodic soil and 71% saline soil. So this is the breakup of salt affected soil according to the share of the share in total salt affected soils. Now the organic matter, there are many more sources which I have already explained in my initial statement, that there are many organic source of organic amendments, like animal manure, then compost and crop residues, and municipal solid waste is one of them, and the organic waste from food processing industries, organic waste from paper mills, timber industries, and brewing facilities, and then post-consumer food waste, home, restaurant, and institutions like that. There are many sources of organic matter. So how best we can utilize that organic source of amendments for the reclamation of salt-affected soils. So now these are the role of different amendment, provide different benefits to the soil. That if you see the compost, if we add compost, it increases our humus in the soil. And then manure and biosolids, if we apply, they improve the soil in lignin content, and then hemicellulose content, and then cellulose content. Similarly, the cover crops, if we are growing the cover crops, they can provide the organic amendment in terms of sugar content, and then cellulose content, and then protein content, and like polyphenols and lignin, etc. So like that, these are the organic amendment provide a variety of food for a diverse soil microbial population in the soil. So now come to the municipal solid waste, which is nowadays a burning issue. The management and disposal itself is a big issue for the government, big challenge for the government. So now, and we can utilize that municipal solid waste as alternate source of organic amendment for the sodic soil. So why we should use that municipal solid waste? This is another question. That availability of FYM, as I have told you, FYM and burning compost is required quantity is a matter of concern, because if the soil pH of any soil is more than 9.5 or 9.6, if you calculate the gypsum requirement of those soils, you will find that we need at least 12 to 15 tons of gypsum. So availability of that much huge quantity of gypsum is a big problem. And one more important thing which we are observing nowadays, the purity of gypsum is becoming a very big problem. Earlier, when I joined at Lucknow, we started the experiment. The purity of gypsum, when we procured gypsum, the purity, it was about 80% or 75 or 80 or 83% purity. But nowadays, if we procure the gypsum and test the purity percent, it is near about 40 or 45 or 46% like that. So purity of gypsum, it's becoming if the purity is less, then we have to increase the quantity to reclaim that based on our GR, gypsum requirement. So that's why gypsum is required in abundant quantity, and that is not large quantity, and that is not available nowadays, the big problem, and costly also. So we have to minimize the gypsum requirement with the substitution of organic amendments. So that's why gypsum, municipal solid waste, can be a good source of organic amendment. Press mud is now utilizing bricklane. Microbial population in soil is reducing due to continuous use of chemical fertilizer. and nutritional value of grains and vegetable and fruits is depleting due to poor plant microbial relation, and municipal solid waste is available in abundant quantities. So that's why we have to use the municipal solid waste compost. You see the data of municipal solid waste. About 19 million ton of solid waste is generated annually and dumped in dumping yards, and disposal of is a open ground dumping or non-sanitary landfill is a big problem nowadays, and that is creating the emanating methane, causing greenhouse effects also. And then the current deployment, given the current development, the generation of municipal solid waste in India in the year 2047 has been projected to be 260 million tons, in number more than 5 times than the present level. So per capita in India ranges from 0.2 to 0.5 kg per day. It is estimated to be increased at a rate of 1 to 1.33% annually. It is increasing annually because of our living standards or our living socioeconomic status and many more things. This production of municipal solid waste in per capita is increasing in the country. If you see the per capita municipal solid waste generation per capita in our India in different cities, so you can see that the Kanpur is producing a large quantity, but the highest is Madras. Madras city is producing 6.657 kg per capita per day municipal solid waste, followed by you can say the Kanpur, and then Lucknow, and then you see the Ahmedabad 585 grams per capita per day municipal solid waste. Likewise, so this is a big problem, that how we will manage in days to come this municipal solid waste. So now come to the Uttar Pradesh, because when I started my experiment, so I have to correct it, the data from Uttar Pradesh and all. According to the Uttar Pradesh, about 5551 tons of municipal solid waste per day is producing from the Uttar Pradesh. And Uttar Pradesh solid waste management is one of the among major challenge faced by the state government, particularly in urban areas. So government is trying its level best, but still we are looking that in our Lucknow city there is many places that are dumping the municipal solid waste is dumping, that because the full management of full amount of the generated municipal solid waste is very difficult for even for the governments. So now you see the status in Lucknow. If you see this is the situation of the photo of Lucknow city, and when we categorize that the based of income, that on income basis that municipal solid waste. So if you divide in the low income groups, they are approximately producing 192 grams per day, and that is 27% waste generation. And middle income group is producing 222 grams per day, and then high income group is producing 261.5 grams per day. Like that, this is the situation in Lucknow city. And now the Lucknow city, you can see this is the Lucknow municipal corporation has divided that land in 110 wards. Our Lucknow whole city is divided into 110 wards and 6 zones for solid waste management, and is responsible for collecting, treatment, and disposal of municipal solid waste generated in the whole city. So like that, the government is trying to manage that municipal solid waste. And the sources of the waste, this is the, you can see the the household is 42%, and restaurant 28%, and street sweeping 6.8%, market 15.8%, offices 4.2%, and hospitals 1.7%, and hotels 1.5%. So this is the total municipal solid generation division or classification according to the source of generation of municipal solid waste. Now come to the feedback. When we surveyed to the city, we found that we collected the feedback from the residents, and they said that that is the groundwater contamination by leachate generated by waste dump. If it is not disposed properly, will cause the following problems it is creating in our society or in our environment. And surface water contamination by the runoff from the waste dump. So sorry. So then the groundwater contamination is a problem, and then surface water contamination by the runoff from the waste dump, bad odor when you are passing from that nearby from that municipal solid waste dump. There is a big, very bad odor like that. Release of greenhouse gases, and then fires within the waste dump. Many places you will find that there is a fire all the time because of this is the heat generated from these dumping stations or dumping grounds. And the epidemic through stray dogs and cows and dogs and all are there using that dumping places. And then acidity in surrounding soils and increase mosquito around the dumping site and affect animal health and disease. You have read in many newspapers that some cow eaten that plastic and this thing died, many cows and many these more things, these things, and we are reading in the newspaper like that. So this is the problem, and we serve it now. This is the physical characteristics of municipal solid waste in our Indian cities. If you see the according to the population range, this data is available from the Ministry of Urban Development, Government of India. And then population range, the cities, those are having population 10,000 to 50,000. The 12 cities, this is the data. And we found that paper, this is the composition of municipal solid waste according to the population density. So you can say the 2.9% is paper, 0.78% rubber, 0.5% glass, 0.3% metal, and then compostable, degradable. We have to focus on this point. So degradable material is available when the population is 10,000 to 50,000. The degradable material is 44%. And then non-degradable, inert matter 43.59%. And then where the population is 0.5 to 1 lakh is 40% degradable. Like that, 38% degradable when the population is 1 lakh to 2 lakh, 38.95% degradable material. And then 56.57, and then 5 lakh and above, 30.84% is degradable material. So how best we can utilize that degradable material for preparing our compost? This is a important issue, so that we can utilize that compost for improving the health of our soils, maintain soil health, and as well as improve the reclamation of salt affected soils. So now the management option, municipal solid waste, there are certain management options which the government is doing. The composting for agriculture use, energy production, biogas and bioenergy pellets for fuels. This is pellets are making. And then infrastructure development. Nowadays, the government is focusing on use of that municipal solid waste for construction of road. But still that research work is going on this aspect, whether we can utilize that for maintaining our road long life. And landfill is also, most of the municipal solid waste is being utilized for landfill purpose. So these are the certain uses, management options for landfill. And now the initiative by the Uttar Pradesh government, what initiated government of Uttar Pradesh, that they are integrated solid waste management project. They have initiated a program in the state. And then government of Uttar Pradesh has established some municipal solid waste treatment plant. And then one of the plant is, you can say this is the integrated municipal solid waste treatment plant at Kanpur. So we have taken this picture from that Kanpur. So the production, they are producing the compost also, but the cost of that compost, this is the market rate of Kanpur. When we visited that Kanpur municipal solid waste plant, we found that 5 kg bag, they are selling at the rate of 250 kg, 250 rupees. So that's very costly. So how, if you want a 10 ton or 5 ton per hectare municipal solid waste for reclamation of sodic soil or for maintaining soil health for our crops, this is very difficult to buy this much quantity of municipal solid waste at a cost of, this is very high cost. So we have to develop some standardize some protocol for developing the municipal solid waste compost at farmers' doorstep. So that's why we initiated the work. So hardly any studies on, earlier there was no study on use of municipal solid waste for the reclamation of sodic soil. So that's why the government of Uttar Pradesh has given me a project to initiate the work on reclamation of salt affected soil. And with these are the following objectives. I initiated that project for reclamation and management of salt affected soil. So first of all, to standardize the method of on-farm composting. This is very important aspect in that the the available compost is very costly. So how we can produce a cheaper compost at farmers level on farm composting? This was one important aspect in our study. And to estimate the rate of decomposition and nutrient mineralization in municipal solid waste compost, monitor the combined effect of municipal solid waste compost and inorganic amendment on improvement of soil health. So because the gypsum itself required in abundant quantity, 12 ton, 15 ton. So if we are able, anyhow, if we can reduce the gypsum requirement, gypsum application quantity of dose of gypsum with the synergistic use of this municipal solid waste, definitely that will reduce the reclamation cost of salt affected soil. The efficacy of inorganic amendments used in conjunction with municipal solid waste compost on sustaining crop productivity in sodic soil. So we corrected for that. We corrected the municipal solid waste from 11 dumping sites from the city, and then we analyzed the composition of that compost, which the composition of that city municipal solid waste which we collected from Lucknow city. It was decomposable waste 36%, plastic 18%, bricks, pebbles like that. This was the composition of our municipal solid waste. This is a sample, mixed sample. Collected from 11 places and then mixed it and make a composite sample and then analyze the physical composition. So we found that there was the decomposable waste was only 36%. So that decomposable waste we utilized for the composting. If you see these are the certain factors affecting the composting process. How we can say that our compost is in good quality compost, or how these are the certain parameters. You can say the CL ratio, moisture content, aeration, temperature, pH, and particle size. Based on these are the certain factors. On these basis, we can say that this is our compost, is good quality compost, or we can say this is the compost is utilizable compost for the reclamation of our soil health. So these are the certain standards that CL ratio for best range should be 25 to 35 and moisture percent 40 to 60%. And so like that, this is the factors responsible for the composting process. Now the chemical composition of composting material. In our experiment, what we did that because we are standardizing protocol for on-farm compost. So on-farm composting means the MSW as well as the जो किसान के पास जो कुछ अवेलेबल है, किसान के घर पर भी उसके पास कुछ पत्तियां हैं, कुछ घास फूस है, या कुछ उसको स्ट्रॉ है, धान का है, भूसा है, जो कुछ उसके घर पे होता है उसको भी वो उसके साथ मिला करके वो कंपोस्ट प्रोड्यूस कर सकता है. So that's why we started the work in combination with, at our research farm we were having the pongemia leaves. This is a plantation, pongemia leaves हम collect किए, then casuarina leaves को भी उसमें मिलाए, then mustard straw mix किए, and then paddy straw mix किए, and then this is the municipal solid waste. So then we analyzed the composition of all these and integrated all these agriculture waste as well as municipal solid waste, so that we can utilize the material available at farmers level, so that he can make a good compost. So then this is the composition: nitrogen, municipal solid waste, nitrogen, phosphorus, potassium, calcium, magnesium, sulfate, total carbon, CN ratio. If you see the CN ratio of municipal solid waste, initial CN ratio was 54.86, and the pongemia leaves 19.11, casuarina 31.69, mustard straw 93.73, like that, and paddy straw 73.42%. So this was the composition of our material which we used for composting of municipal solid waste compost in combination with agriculture waste. Now you can see this is the technical program of our study. We initiated this composting process with the 7 treatment. You can say we used 100% municipal solid waste, and then 100% municipal solid waste plus microbes, and then 50% municipal solid waste plus 50% agriculture waste plus microbes, and then 100% municipal solid waste plus earthworm. We added the earthworm. Earthworm Usina foetida is a very fast decomposing this earthworm species, so we used that. And then 50% municipal solid waste, 50% agriculture waste plus earthworm, and then 100% municipal solid waste plus microbes plus earthworm, and then 50% microbes plus earthworm both. So this was the treatment combination, and you can see the picture. We filled these in the Burmese beds. and follow the complete protocol of the turning and continuous turning and taking observation, temperature, moisture, and all these parameters, all these observation we took at and the cultures, microbial cultures which we used were the Aspergillus, Trichoderma, and Bacillus. We used to decompose this municipal solid-based compost. Now we monitor the changes during this composting process. We are regularly monitoring the changes. If you see the temperature, and initially there temperature was less, and then slowly the temperature increased, and then again come down and then stabilize. So at 120 days, we can say in 120 days our compost was completely ready for use for the you can say for soil fertility management, or you can say soil health management, or you can say soil reclamation of salt affected soil. So like that, and similarly the moisture content we observe regularly. Initially moisture was very high, and then slowly it reduced, and at 120 days moisture it was stabilized, and it was moisture within the permissible range. So similarly, change in pH and EC, we analyze regularly pH and EC at 15 days interval. We were correcting the samples and analyzing regularly then pH and EC of the composting material. Now we are also monitoring the CN and CP ratio during the compost under different treatments. And if you see, and there was not much difference after 30 days but it was reducing up to 120 days. The CN and CN ratio was decreasing in all the treatments. But the maximum reduction in you can see in treatment P6. So like this was the CN ratio, and then CP ratio also after 90 days the CP ratio was almost stabilized. So but it reduced slowly when the decomposition was going on in the Burmese beds. The change in enzymic activity, we were also monitoring enzymic activity. If you see the alpha amylase, and then this is the gyanidase activities. So there were also changes in with the time, changing in time. These activities was also changing in the municipal solid-based composting. Nutrient status, nutrient content. The highest total nitrogen was estimated in the treatment T7. Total nitrogen content was the highest in treatment T7, and then highest total phosphorus was recorded in the treatment T2, followed by the treatment T5, T7, like that. And then highest total for potassium was found in treatment T5.7% and lowest with treatment T2. This was the our data. And now the chemical composition of on-farm and industrial processed. Now we compared our product, our product which we developed. We compared with the industrial product. The industries are also producing the compost. We collected that industrial product and then compared the composition with our product which we developed. This is our product. You can see this is the team of the government of Uttar Pradesh with the funding agency. They visited and see their site, and this is our end products. So we see that pH of this is the industrial processed municipal solid waste compost. The pH was 7.48, and our product was pH 7.48, 7.54, 7.9, like that. And the best product which we claim that this is our best product, best treatment, was 7.36 pH. And the EC was non-significant between the treatment, and total nitrogen in our product was 0.79%. However, in industrial product, it was 0.3% total nitrogen, total phosphorus, like that. So this our product was our product on-farm composting product was better compared to the industrial products in terms of nutritive value. Now the microbial property of on-farm compost at initial and maturity stage. If you see the microbial properties and in bacterial fungus initial, and then after 120 days there was significant improvement in the microbial population of the product. The highest population of bacteria, fungus, and phosphates solubilizing microbes at initial and 120 days was recorded in treatment T7, where the lowest in the treatment T1, T6, and T2, like that. So you can say that this microbial population also changed because of the composting process or addition of the microbial microbial amendment in the treatments. And now the heavy metal micronutrient and heavy metal concentration in our on-farm compost. If you see, the heavy metal like arsenic, cadmium, nickel, lead are below the detectable limit in the samples through analyzed samples. So these were not there were no any harmful or any heavy metal content was higher in our product, which may be harmful to the soil. So they all were in the permissible limit. Now though this is the end, this is our end product. You can say this is the composition of our end product, which we used for use in conjunction with gypsum in the reclamation of sodic soil. So this was the pH of our product was 7.36, EC 0.66, total nitrogen like this 79. So this is our bacterial population 75 into 10 to the power 5, fungal population, PSB population, and CN ratio. CN ratio, this is 17.13 after 120 days of composting. So it was very good compost. If the CN ratio is below 20, you can say that is a very good product for improving our soil health and fertility. So now we analyze it. At the same time we analyze the cost of production of that municipal soil. So at the end, we calculated that our product rupees per kg. You can say the 41,400 for 10 ton. 10 ton to produce 10 ton on farm compost. Our cost of production was rupees 41,000. In which we can say that the Burmy bed cost is 5 number Burmy bed which we purchased for this. The Burmy bed cost is rupees 12,500, and these Burmy bed once purchased can be utilized for at least 5 years. So this cost can be divided, even if we reduce this cost divided by 5, then definitely this cost will be reduced. So major cost is on account of the purchase of the Burmy bed. The farmer can no need to purchase Burmy bed. They can make a heap, or they can make a structure, brick structure, something like that. So that once this structure is developed, and that can be utilized for a longer period to make the composting process. Now the question, once the product you have developed, now the question arises that how much quantity you have to add in the soil. So optimize the quantity of dose. For that, initially we started the pot experiment on mustard and wheat initially, immediate after the producing of our compost. And then for that, we filled the soil in the pots. The pH of the soil which we utilized was 9.2. And this is the composition of soil which we filled in the pots. And they started to optimize the quantity of municipal solid waste compost. That without optimizing that, how we can't say that this much quantity of compost we should be used in the soil. So this is the property of the soil which we filled. So that we find that on the basis of our the spot experiment, we find that 10 ton the maximum grain yield of mustard we found with the addition of 10 ton municipal solid waste compost. So we can say that 10 to 15 ton. In case of mustard, we find the highest yield with 10 ton per hectare. But in case of wheat, we found highest yield in 15 ton municipal solid waste compost so we can say that 10 to 15 ton municipal solid waste we have to use for the reclamation of this soil. So that's why, based on this 1 year only, this was only 1 year pot experiment, we can go now, we can go in the field with this the quantity of municipal solid waste compost. Now come to the field experiment. Now once we develop the product, we have product in our hand, in our basket, and now we optimize the quantity. Our product, we have found that physical, microbial property, everything we have analyzed, and now we go to field to monitor the performance of that product. So this is the our field experiment. When we started, you can see the pH where we started the work. This municipal solid waste pH was 9.8 and ESP was 78. Organic carbon was 1.30 grams per kg, or you can say 1.13% organic matter in the soil was very very poor in organic carbon content when we started the experiment. This is, you can say, this is the field where we initiated the work. And now with this we have taken eight treatment combination in this experiment. Gypsum, 50% gypsum. This is our prevailing practice, which general practice, which we are recommended practice, you can say. And then phosphogypsum, another source of gypsum is phosphogypsum slowly, and this is the product of the byproduct of the phosphatic industries. So we have to, nowadays it is coming that for certain phosphatic agencies are claiming that that can be useful for the reclamation of sodic soil. So that we took that also in our experiment to compare with the gypsum. And then gypsum 25% GR plus decomposed municipal solid waste 10 ton per hectare. Then phosphogypsum combination 10 ton per hectare. And then gypsum, we reduce the gypsum quantity from 50% to 25, 25 to 12.5, and then 12.5% gypsum and 12.5% phosphogypsum plus decomposed municipal solid waste, and then 25% gypsum plus industrial process municipal solid waste. We also compare the industrial product with our on-farm composting product. So similarly, the phosphogypsum in combination with industrial process. This was the experiment which we started. We initiated at our research farm at Lucknow. Then the crops was rice wheat cropping system, and plot size was very big plot size. You can say 90 square meter plot, and you see. So this is the imposition of the treatment. When we started, this is our compost product, and this is our gypsum. We spread the gypsum and then mix in the soil. First, we mix the gypsum, and then this is the leaching process, complete protocol for reclamation, and then we leaching of the salt, put the water for 10 days, continuous ponding of the water, and then use that municipal solid waste. So this is our complete protocol. And now the phosphogypsum, you can ask the question, what is the composition of phosphogypsum? So this is one slide for sharing with you all that phosphogypsum is also equally, it is having the calcium 18.9%, and similarly gypsum is having this 18.3% calcium. So like that, this is the equally, we can say the composition wise is equally effective as mineral gypsum, but its availability itself is the phosphogypsum is very difficult because there were phosphatic industry. Most of the phosphatic industries are Paradip phosphates like that. They are far away. So transportation cost of this phosphogypsum is very costly. So, but anyhow, we have to find out the alternate for the reclamation. And the organic amendment on physical properties, effect of organic and inorganic amendment when we used in the soil. So you can see this is the initial bulk density of the soil was 1.59, and slowly when we use these treatments, the initial bulk density of surface soil reduced, and the hydraulic conductivity, initial hydraulic conductivity was 0.08, and now it increased to 0.75 in treatment T4. Similarly, sand, silt, and clay, there was not much significant difference, but definitely there was improvement in soil physical properties of soil after addition of this amendment. And then chemical property, we come to the chemical property after 3 years of rice wheat cropping system. The pH was, you can see the maximum reduction in soil pH was from 9.8 to after 3 years pH reduced to 8.8, and in treatment T3. And then EC 0.44 and ESP, which was 78. After 3 years, continuous rice wheat cropping system, ECP reduced to 28. And the organic carbon, which was 0.13%, you see in earlier slides, it increased to 0.35 or 3.5 grams per kg. So this is like that. Available nitrogen increased, and so there was tremendous improvement in the soil in addition of with the combined application of organic and inorganic amendments. And now, soil microbial properties, come to the microbial properties after 3 years. Bacterial population initial, if you see the initial population, it was 1.3 into 10 to the power 6, and now it increased to 9.2. So there was significant improvement in terms of soil microbial properties. But the maximum improvement, if you say, it was in the treatment T8, where we 9.5, or treatment, or you can say the treatment T3, where 25% gypsum plus on-farm municipal solid waste compost was applied at the rate of 10 ton per hectare. In case of this treatment T3 and T8, it was at par in the terms of fungal population, and the maximum bacterial population, it was highest in treatment T5, where we applied 12.5% gypsum plus on-farm compost plus press mud. In this treatment, we add the press mud at the rate of 10 ton per hectare also. So this is the combination of two organic source of amendment like that. So and now come to the organic amendment on bacterial and fungal population. This is, I have already explained in my previous slides. And now come to the heavy metal content. If you see, the heavy metal content like cobalt, chromium were reduced over the initial value, and found lower than the permissible limit. However, lead increased over the initial value, but below the permissible limit ascribed by this Sultanpur and McLean et al. 1987. So this is the lead content was little bit, this is the initial 0.113, but in our treatment, this lead content increased because of addition of this municipal solid waste, or you can say the integration of agriculture plus municipal solid waste compost. Now this is the organic carbon and available nitrogen content status. This was also improved in after 3 years of continuous rice wheat cropping system. And now crop growth. Now come to the crop performance. If you see the performance in the same field where nothing was grown, there was no, the pH was 9.8, and you can understand very well that some of my participants may be belonging to that area where having the salt affected soil. In salt affected soil at 9.8 pH, you can't even grow a single penny without any amendment. So in that case where the nothing was grown, we have to, you can see the crop of rice crop in that same field, and this is the wheat crop in the same field. The crop product, if you see the now we come to the this is the rice and this is the wheat. These are certain plant growth parameters. So no need to explain this too much. Now come to the grain yield. Now come to the yield of rice. If you see the maximum 4.8 ton per hectare, this is the average of 3 years. So 4.8 ton per hectare we yield rice, and you see 2.4 ton per hectare. This is in case of wheat. We got after 3 years. This is the average in the treatment where we apply 25% of gypsum, reduce gypsum 25% from 50% to 25%, and add municipal solid waste compost. We get maximum yield, followed by treatment T6 3.7, 4.7, like that. So this was the yield we got after the addition of municipal solid waste compost in combination with chemical ameliorant. Now this is, if you see the net return and benefit cost ratio of rice wheat cropping system, you see this is the this cumulative net return. You see the first year, 1 year, first year, and 1 plus second and third year. A small positive net return was obtained with the treatment T6, where reclamation cost was very less due to addition of very less quantity of gypsum. However, net return was negative in all remaining treatments. You can see this is the negative. This is the negative net return. But after this is the cumulative. If you see the cumulative BC ratio, positive BC ratio during first year of reclamation, followed by rice wheat cropping system, was obtained in only treatment. T6 treatment was positive BC ratio. However, in second year, there was positive BC ratio in all the treatments. So this is the cost economics of the study. And now you see the nitrogen, nutrient concentration in grain and straw. You can see the question that whether it is in the food chain, whether there's any effect of the addition of municipal solid waste on food chain. So that's why we analyze the NPK content in wheat, grain, and the straw. The maximum nitrogen content in rice grain was recorded with the treatment maximum was this is it is covered with T4, where highest nitrogen concentration in straw was observed in treatment T3. Maximum phosphorus concentration in grain as well as straw was recorded in T3, followed by T4, and minimum with T1. The highest potassium concentration in rice grain was observed in case of treatment T4, which was at par with T3. So this was the status of nutrient status in grain and straw. So this is all about my presentation. Now come to the conclusion slide. This is last slide. The conclusion, we can say that combined use of municipal solid waste and agriculture waste for composting is an alternate option to municipal solid waste management. And then municipal solid waste compost prepared through on-farm composting with 50% municipal solid waste plus 50% agriculture waste, enriched with the earthworm and degrading microbe strain, produced nutrient-rich, cost-effective quality compost. This is our product. And then sodic soil treated with on-farm municipal solid waste compost at the rate of 10 ton per hectare in conjunction with the reduced dose of municipal solid with gypsum or phosphogypsum has been successful in improving soil physicochemical and biological properties. And then adoption of this approach will save 50% gypsum or phosphogypsum requirement without any significant loss in grain yield. Very important that there is no significant loss in grain yield, And even after reducing the gypsum requirement from 15% GR to 25% GR with the substitution of 10-ton municipal solid waste compost. With the introduction of this technology, about $433 per hectare may be saved on account of reducing gypsum, 25% gypsum by using on-farm MSW compost in the soil. So this is, thank you very much. This is all about my presentation. Thanks to all for patience hearing. Thank you, sir.
Thank you so much, sir. As sir told, sir is suffering from the cold. I'm sir very thankful for the Dr. YP Singh sir for sparing some time with us for in spite of suffering from this cold. And sir, actually, sir very nicely presented this topic regarding the waste management. We talk about the if we consider the Swachh Bharat Abhiyan. So we are doing the waste management. We consider the last level of the waste management is very, very important. And sir very nicely explained how we can manage the final waste management and how we can convert that waste management in the beneficial for the agriculture. And sir, as sir very nicely explained the sodic soil management. If we consider about the most of the eastern part of the UP considered, most of the part is very much affected by the sodic soils. And I have gone through the sir's work, and the very nicely sir covered all the topic how we can manage the sodic soil management. Sir very nicely explained about the role of the weather parameter in the management system. As we know, the enhancing of the 1 or 2 degrees Celsius temperature in the waste management, in the decomposition, the bacterial activity enhance very much. So sir very nicely and explained about this topic. So sir also explained how we can standardize this management and the selling of the composting material. As I sir told, most of the sellers are selling these composting materials at a different rate level. We should standardize the label for the farmers so they can buy at a efficient level. And I'm very thankful, sir. Thank you so much, sir, for sparing your valuable time with us, sir. Thank you so much, sir.
Thank you, sir. Thank you very much. Thank you, sir. My pleasure. My pleasure.
Very happy to, sir, announce that Dr. Anil, sir, from the CSSRI Bharuch is with us. And Anil, sir.
I think he is from your department, sir. And he want to share his views with you, sir. Please, Dr. Anil, sir.
Sir, good morning.
Good morning, sir. Good morning. Good morning, sir.
कैसे हो?
ठीक है सर, बस तबीयत थोड़ा ढीली है.
Okay.
जुकाम हो रहा है और कल से बुखार भी आ गया है.
Take care. You have given very good topic and deliberation also.
Thank you, sir.
Regarding sustainable management. And Dr. YP Singh is a renowned agronomist.
Thank you, sir.
And he has been working in the sodic soil management since last 35 to 36 years at our regional research station of Central Soil Salinity Research Institute, Lucknow. Recently, he has been working on municipal solid waste management, and he has made some protocol for formation of that municipal solid waste into the compost. And he has been given this technology to the different stakeholders. In addition to increasing the nutrient of the soil, it also helps in sodic soil reclamation, that compost. Sir, you have nicely explained to the participants, and I hope they will be very much beneficial from your lecture, and they will take some guidance in future if it requires from you. So about this College of Agriculture, you know, you have visited my station also, sir?
Yeah.
Last, I think 3 to 4 years back, and we are nearby adjacent, and we are doing much more activities in collaboration with College of Agriculture related to research and even some additional laboratory facilities. So in combination, in collaboration, and in synchronization, we are working with College of Agriculture, Bharuch. So your lecture will be most helpful, and I am very much thankful, sir. You have given your time in spite of your sickness, suffering. Let me come to the participant. Dr. Y.P. Singh Saab is also a in charge of Krishi Vigyan Kendra at which that is allotted to our CSSRI Lucknow, which is at Hardoi. Is it, sir, Hardoi, na?
Yeah.
Yeah. So he is looking after for that also, and he is very much active at this at KVK, and he was very much good scientist in CSSRI regarding sodic soil management. Thank you very much.
And superannuating on 30th June.
Yeah, he is also. I purposefully did not say that thing, sir. We need your services. Don't be. मतलब हम नहीं चाहेंगे आपको छोड़ने के लिए. Thank you very much.
Thank you, Y.P. Singh sir.
Thank you for nice words. Thank you, sir.
Our College of Agriculture has a very good relationship with the ICR center nearby our college, CSSRI. And thank you very much, Dr. Y.P. Singh sir. Our next eminent speaker and renowned wheat scientist, Dr. Anil Dixit sir is here with us. And now I request to Dr. Alok Srivastav, please introduce our new eminent and renowned scientist, wheat scientist, Dr. Anil Dixit sir.
Thank you, Dr. Edipur sir, for giving me this opportunity. As I know personally Dr. Anil Dixit sir, as I also belongs to Chhattisgarh Raipur. So without taking much more time, I would like to talk about Dixit sir. Dr. Anil Dixit sir completed his graduation with gold medal from IGK Raipur, and I also alumni from that college. He was recipient of ICR Merit Scholarship during this period. Dr. Dixit obtained his master degree as well as PhD degree from prestigious IRI, New Delhi, and awarded ICR Merit Fellowship during this period. He started his career from Directorate of Wheat Research Station, that is Jabalpur, as a IRS scientist in 1993, and promoted as principal scientist through direct selection in 2009. As a wheat scientist, he was promoted with experience over 27 years as a wheat scientist. Dr. Dixit made valuable contribution in the area of wheat science, particularly in managing wheat through integrated wheat management and herbicide technology. He has given stress from the field of competence in herbicide to the research which has got relevance to the immediate farmer use. That is very notable, and he has made outstanding contribution in the area of integrated wheat management in crop as well as in cropping system too. Dr. Anil Dixit was appointed as nodal officer for Krishi Kalyan Abhiyan run by Ministry of Agriculture, Farmer Welfare, Government of India. It's one of the flagship programs running by the Government of India for inspirational districts of Dantewada, Sukuma, and we know very well about this Dantewada, Sukuma. This is the Naxalite belt area in Chhattisgarh, and Dr. Anil Dixit has conferred with Best Scientist Award from Institute, Crop and Wheat Science Society Fellow Award, Indian Society of Wheat Science Fellow Award, and many others from professional as well as government bodies. Dr. Anil Dixit also awarded most prestigious Fakhruddin Ali Ahmad Award. It's one of the famous awards that's given by ICR National Award for outstanding research in tribal farming system in Bastar region in 2019. Dr. Dixit recently awarded Outstanding Agriculture Scientist Award in year 2020 from B.V. David Foundation, Chennai. Apart that, he has spreaded 250 publications in the form of research paper, article, book, bullet, chapters, presented paper of national or international report. Dr. Anil Dixit has made as overseas visit to IRRI, that is International Rice Institute, Philippines, and Thailand for his academic and research excellence. So without taking much more time, I would like to invite Dr. Dixit for today's talk and blessing word. Over to Dr. Dixit sir. Dixit sir. Dr. Dixit, can you hear me? Dixit sir.
Hello, Dixit sir, unmute yourself.
Please unmute yourself, Dr. Dixit sir, please.
Hello.
Yes, sir. You're audible now.
Sorry, actually, there was a mistake in the choosing the microphone. Sorry. So, okay, thank you, Dr. Alok, for making a nice words for me. And I know Dr. Patel also from the beginning, and we had a very close association. And it's really, from my side, thanks to the organizers for choosing me as one of the eminent speaker in the area of wheat science. So thank you to all of you. So let me begin with the talk about the recent trends in the weed management. So as you all know that weed is one of the important area where we may have a this thing losses due to weeds are much more higher as compared to the other biotic stresses, because this institute is the National Institute of Biotic Stress Management, and we are dealing with the weeds. I am heading this weed science department here, and the other areas of plant protection are also being dealing in this institute related to disease and the insect part. So this weeds is the most devastating problematic in the crop area and non-crop area. And if you compare the different losses due to weeds, if you consider long back in the 1988, the figure was the 2000 crore, and the losses, it went up to 1 lakh crore in 2008, and recently 2018 study which was carried out by the different AICRP Center of Weed Management Program. So there we come out with the losses to the tune of 70 to 80,000 crore annually. And present scenario of pesticide, if you look at that herbicide in the global scenario, herbicide is accounting the most higher side. As compared to the Indian scenario, the herbicide contribution over the pesticide consumption is only 18 to 20%. So this figure is not a good this thing that still the many of the states and the many of the farmers, they are also not using much herbicides as compared to the other pesticide. The focused area of research in the weed science in India, if you talk about, then the period started before and during 1980s. The focus area was related to the weed survey, documentation, crop weed competition, herbicide screening and use in cereal crops. In 1990s, the focus area was to the invasive weeds, and the invasive weeds, among the invasive weeds, the Phallus minor and Parthium lantana, these three major weeds were there. And some of the studies on the herbicide screening, because the many of the industry people, they are interested to get the register of the new molecule. So most of the ICRP Center and the Weed Science Institute were focusing on the herbicide screening trial also, which is being used in the pulses, oilseed and the commercial crops. Then in 2000, the system approach in weed management concept came. And in totality, the weed management program was running, maybe related to the rice weed system and the other management, horticulture crop, herbicide residue, resistance in weed, aquatic weed, water hyacinth, salvinia, herbicide tolerant crop. So some experiments on the maize, mustard, cotton, soybean. Now the most of the weed science program is running on the low dose, high potency herbicide molecules, maybe related to the herbicide mixtures also, because most of the industry, they are interested to come out with the formulation product of mixing combination, that is a premix or ready mix combination. Herbicide residue study is the study which has to be carried out for longer period, because anytime the residue issue may come, Then resistance issue is also problematic, because the whatever the molecules are coming, especially the Punjab Haryana belt, where the that is basically a rice wheat system, and this falris resistance problem is because of the system which we are prevailing, mainly rice wheat system. So there, although also the resistance program is in a bigger way. I will in my later part I will tell you how to deal with the resistance species of the weeds. Then crop wheat interaction under climate change is, this is also area where, because of the climatic change effect and the higher in the carbon dioxide concentration and the other issue, we have to deal with in a more focused way. Then conservation agriculture, this practice was there in the age-old practices, but now the conservation agriculture program in a more in a strong way and very comprehensive manner, this program is running in entire country, and many of the players, partners, they are doing a good piece of work in the area of conservation agriculture. We have also proposed in the NSF about the conservation agriculture program, because this is the institute which are dealing with the most of the biotic stresses component, whether it is a weeds, insect or disease. So in totality, the role of conservation agriculture, we know about the weed flora. That is true that over a period of time the weed infestation is being reduced, but at the same time the problem of perennial weeds is getting more problematic. So and the what are the pest dynamic relationship related to the conservation agriculture, that we are also not knowing. Under the organic farming also, precision farming systems, all in the production dynamics production system, this kind of study is very much important, and the NSF also interested to know about this conservation agriculture under different production system, what kind of pest relationship and the dynamics is there. If you talk about the major problematic problem weeds in this thing in agriculture, the cropland situation, the most of the filarius, echinoclova and wild rice is also getting problematic nowadays. Aziratum, cypress, cynodon, parthenium. So these are the list of weeds which are more problematic in terms of cropland situation. In non-crop situation, parthenium, lantana, mecania, mimosa, aziratum, promina. So most of the non-invasive weeds, and these weeds are more problematic if you talk about the Assam region, Kerala and the Karnataka. So these weeds, these invasive weeds are getting problematic in non-crop situation. And what about these? The water hyacinth, Salvinia, Pista, Typha, alternatus, these are the major weeds, and work is going on. And because in the water bodies, we cannot go blindly for the use of chemicals. So we have some restrictions of using any kind of weed management technology in the water bodies. So mostly this program is focused on the biological control. And the biological control, the limitations are there. So I'll talk later in this presentation. And the parasitic weeds, these three weeds are more problematic. Orobanki is there because I visited in the area of Rajasthan and the Haryana area, where in the mustard Orobanki is very problematic, and Striga is there, and Kaskuta. So these three parasitic weeds are getting problem in the different agroclimatic zone and the different cropping system. And if you talk about the stakeholder concern, so certainly the invasion of new weed species is the major problematic to the stakeholders, because whenever they are going for a different kind of production system, then they may come across with the new kind of invasion. So this is also a concern. Then the manual weeding is very costly nowadays, and getting a labor, and during COVID time also, we had a very tough time getting a labor on time, and their availability, the cost is increasing. So these are the issues where the manual weeding is sometimes very cumbersome, and it almost impossible. Then another point is the application technique of herbicides. The application technique of herbicides, many of the we had even discussion on the by the task where the Dr. Paroda Saab is the chairman of that organization. So they conducted one day deliberation regarding the herbicide policy issues. So nobody talked about the application technique. So whenever I am using a platform, I used to focus on the whatever the pesticide use is there. You have to focus on the technique application technique part for the case of herbicides, because the herbicide is a chemical which has to be applied on the living plant. Whether we have to kill the weeds, but again weeds is a living plant, and again the another living plant, that is a crop, we have to save that crop. So using a technique is a very important part. Then non-availability of herbicides and the mechanical tool. This is also a major concern to the stakeholders, that sometimes their availability of the herbicides in time is also not this thing. Costly spurious chemicals, this is also a major concern. We had a tough time in the Punjab issue where the lot of spurious chemical was flooded in the market, and you know that case very well. And this spurious chemical material is the problem in other states also, so that we have to standardize this thing, and the mechanism of the whosoever involved in these policy issues or from the government sides, that they have to be very tough dealing with these manufacturers and the dealers who are dealing with these spurious chemicals. Then sometimes large packaging of herbicides also a matter of concern, but most of the manufacturers, they are coming with these packets which are friendly to the use, and they can use it very well. Registration of new molecules also concerned. Many times we are getting a molecule which are there in the market for the 2 years, then again third year or fourth year onwards that molecule gets away from the market. So that is also a major concern. And the lack of awareness, extension efforts, this is a well-known drawbacks and the major matter of concern. And another issue of the weeds which are no man's land. So who will deal with, who will control those weeds? Who will deal with that kind of situations? That is also a concern. And the last point, which are of very important, because recently we have come across with the ban and restricted use of popular herbicides. And in this situation, the most of the chemical which are of very friendly, which are of no residual toxicity, that those chemical also put in the question mark. So that is a matter of concern. So most of the point I have covered in this previous one. So the little bit I will talk about the ban and the restricted use. That proposal was to ban 27 pesticide, and among the 27 pesticide, the 7 herbicides are there. So what are those 7 herbicides? It is atrazine, pendimethalin, diuron, 2,4-D, oxyfluorophil, sulfosulfone. If you say that 2,4-D is the most commonest herbicides among the farming community, and the biggest advantage with this 2,4-D is that this is a very cheaper molecule. And if you talk about the control of broadleaf weeds in the lawn and the other area, this is the answer. Likewise, pendimethalin is the molecule which are being used in most of the cereals, pulses, oilseed and vegetable. Even as of now, we don't have a herbicides which can control the broadleaf weeds in the pulses, because we don't have any post-emergence herbicide for the pulse crop also. So pendimethalin is the answer, where we can have a control of 60% weeds in the such crops. So banning such molecules is again this thing. Of course, that government has put this thing, this thing, and decision has to be taken later part. But this sort of and another popular herbicide is glyphosate. We have seen the glyphosate use in the different platform, and glyphosate is the most widely used herbicide globally, and also in the cropland and non-crop situations. And what they have proposed by the government side, that glyphosate should be used as a restrictive use, and in the restrictive use they have mentioned about the PCOs, that pest control operators. So where the pest control operators are running in the village, I don't find any PCO in the villages, and this is again going to make a more complications for using glyphosates. Coming to the operating environment in the present and future, labor already I have touched about the chemical weed management. The problem in the chemical weed management is about the herbicide resistant spurious many chemical. Herbicide residue hazard is also there when we talk about the sulfosulfuron. If sulfosulfuron we are using in the higher quantity, or if sulfosulfuron is being used in crop, and that follow-up crop is being used like soybean and this thing. Suppose this sulfosulfuron generally used in wheat crop, and if you have taken a kharif crop soybean, then there is a chances of having a residual toxicity in the following crop also. Then there is a issue of herbicide tolerant crop. This is the area where we can have an answer of controlling many weeds in this situation. And changing climate, definitely the problem of C4 weeds will be more, because the most of the weeds are coming into the C4 because of the most photosynthetic this thing. So this problem of C4 weeds will be there. Then alternate protection system is the concern, and problematic weeds already I have talked about. So coming to the weed management options, what we are having a weed management option at the present level. If we talk about the tillage crop establishments, that we have a FURBs and the ridge and furrow system in the lighter soil, because the use of these kind of technology helps in controlling the fellness manner in the rice field system. And stem seed bed technique is the very age-old practice, and certainly in many of the area, the using of stem seed bed also is still a technique where we don't have an answer of many weeds. So this technique also being used. And coming to the crop management, the definitely the whatever the this prevention methods are there, clean crop seed and sowing date methods, and the variety fertilizations, how you can manage the nitrogen fertilization. So these all sort of options are there when we talk about the non-chemical approach. So these are the in a nutshell I made this thing to tell you about the what are the options are there for to the farmers. Coming to the research thrust, what are the recent trend areas? So I have listed out some of the points which are of much important. You see that weed biology and the crop weed interactions. This certainly will be the most area where we can have a understanding and mechanism of interspecific and intraspecific competition, because a better understanding with the environmental factor and affecting the weed seed germination, these sort of studies are very much important. And demonstrate approaches to improve the crop competition with the weeds, whether it's a altered crop growth response or the enhanced allelopathy, that needs to be understood in a better way. So this study weed biology and crop weed interaction is a very important area. And I'll tell you that not much of the weed scientists or the agronomists, they are making such kind of study at their stations and institutions. And the second area of herbicide safer low use synthetic product. So when we talk about the low dose potency of the herbicides, certainly this area needs to be more strengthened and should be studied in a more better way. There are certain issues where we talk about the different interventions for dealing with the herbicides, like RNA-based herbicides, how this does resistance, especially non-target site resistance. So this sort of all sort of study needs to be taken care, and certainly issues of herbicide resistance. I will show you how the herbicide resistance mechanism can be studied in a better way. That I'll tell you in my later part of the presentations. The third one is the precision agriculture and robotics technology. A lot of I have seen the literature where in the foreign country they talk about the site-specific weed management, remote sensing, and GIS, machine learning, deep learning. So all sort of system needs to be able to locate the weed spot in real time and manage to spray to desired chemical only on the proper location. So this sort of is technique which needs to be studied in a better way. The thermal weed management is also a technique. In India, we always talk about the soil solarization, but not much headway has been done on the flame weeding or the weed japper, electrocution. So this sort of technique also to be introduced in a situation where we don't have an answer of herbicides. Then we talk about the biological control. The biological control also because of the certain conditions and the this host specific issue and the other parameters. Sometimes this process is very slow and we don't get the much control of weeds through the biological control. But this non-chemical approach has to be strengthened, and the most of the I have seen in the controlling the insect through pheromones or the other this thing trichoderma and the other this thing bacterial culture. So again, the weed management program also to be strengthened with the help of molecular basis of pathogen this thing, and certain technologies of genomics and the proteomics, use of omics we used to in short we used to say. So these are all sort of interventions are required for dealing or handling the biological control in a most better way. Then extension education economics is the area where for the data management system for the this thing IoT is there, internet this thing learning of things, and the food safety and quality issues related to the herbicides, the herbicide monitoring on soil, water, environment, and these all sort of study will be carried out, and it's need a more comprehensive manner to come out with the all sort of problem or the questions, whether it's problematic or any herbicide residue issues are there. Then always we talk about the this thing, but controlling. But we should focus on the utilization part also, because every plant species is important. Always talk about the controlling and this thing management. It's not a answer. So we should focus on the composting. In the previous lecture, we were discussing about the many this thing. And phytoremediation technique is there. Some Orondodonex is the weed, where we had one trial, and we have shown to the municipal corporation also that how the heavy metal water you can use it for the potable purpose, not for the drinking purpose, but for the other purposes we can use it, that heavy metals infested water. And certainly you might have seen the most of the weeds also, they are having a medicinal properties, whether it's a allelopathic medicine or the homeopathy. So these sort of this thing is there, and always the scope of basic research is there. So that also needs to be strengthened and studied in a more comprehensive way. So these are the future technology innovations. Biotechnology, it's related to the stake genes. We have seen the genetically modified crop studies. Of course, that was the bioefficacy study, which was of some industry. Then nanotechnology, we always talk about the nanotechnology. Nano formulations are there, so we can come out with the low doses of herbicide use by using the nanoparticle and nanotechnology. The novel chemistry herbicides, this is also area where we can have a more this thing. and the CRISPR, RNA, omics, this all biotechnology interventions are needed, because we have seen the most of the weeds are having a rich biodiversity, which having a rich source of many genes. So using these kind of interventions, we can come out with the identify some of the genes which can be transferred in the crop plant, and then we can have a certain area of this thing for weed management, and then there we can control the weeds in a with this technology. Then micro and bioherbicides, this is the area which we can also think of, and many of the pathogens and the, because in the textbook we have seen the divine and this thing colego and the old this thing, but as of now there is I have seen the one paper, policy paper has come out in the NAS, this thing related to the bioherbicides. Dr. Mukhopadhyay has very well written about the issues related to the Indian context. So this issue of micro and bioherbicides also needs to be studied in a more better way. And certainly these sort of bioherbicides are very much important, where we should minimize the chemical use. Then phenomics is the area which we can have interventions for better weed management program. Microwave laser technology is there. Robotics, drone, artificial intelligence. These are some of the area where we are making a much headway in the different technology interventions. And now this is the time where we can come out with this such type of robotics, drones, artificial intelligence. You can put all these programs in the computer system, and then you can use it drone with the help of your laptop or this thing, all sort of this thing. And the allelopathy is the area where we were talking about for the last 20 years, but I have not seen any kind of this thing which is commercialized or which has a sort of course we talk about for controlling, suppose Casia thora is there, that it controls the Parthenium, but again the scattered kind of study coming for the writing paper only, this sort of business we have seen, but certainly there are certain we have a trial at Raipur regarding the allelopathy, and we have screened some 250 germplasm of rice germplasm. There we have seen that some of the rice varieties are there which automatically taking care of weed management, means the infestation of weeds are minimized in certain varieties. So we are going for the second phase of study for chemical analysis and the metabolite study. So there we can have answer. So this is the role of various organizations in the herbicide resistance management. So herbicide resistance management, why I'm focusing here, that this is the very much concerned area, and most of the herbicides which we are using, or the many of the new herbicides which are of kindly tell me the time now, please, because I will keep on speaking because it's such a vast area, and already I have studied for means 28 years in the weed management, and weed is my this thing. So you just give me the
Okay, sir. 45 minutes given, but you can take 1 hour, sir. Okay, not very sir.
okay. Okay. So role of various organization in the herbicide resistance management. So if we talk about the suppose this pesticide industry part, so pesticide industry part, they have also duty to come out with the developed low risk novel broad spectrum herbicide, because they have a well established program of development. Many of the agrochemical institutions and the organic chemistry people, they have worked on the many of the product that it has the pesticidal property or the herbicidal property. But if we talk about the commercial value or the commercialization, then our answer is no, zero. So again, we are dependent on the pesticide industry. Whatever the molecules are coming, whether it is a herbicide or the insecticide. It's coming from the pesticide industry because they are also taking this molecule from the China. Previously, they were taking with the Japan, but getting this generic material from the China is very cheaper, and everybody thinks about their economics. So this sort of business is there. So their effectivity and the labeling guidelines, this all comes to the part of pesticide industry. Then only we can manage the herbicide resistance in a better way. When we talk about the environmental agency, then the registration issue, research extension, and the different integrated weed management this program. So this sort of governmental agency needs to be studied and strengthened in a much better way. We talk about the academician and the institution. They are the education, training, and monitoring of herbicide use and this part. So their responsibility to manage the herbicide resistant issue, and the end user, the farmers, they should be they should know about their history, crop cultivation, variety of choice, adoption of different management techniques. Then in the management part, if we talk about, then the herbicide rotation and the different, it's not necessary that you keep on dependent on the single molecule. Then you need to be this thing rotate. Then only you can come out the herbicide resistance solution. Already, I have covered a lot on this thing biotechnological issue, so I need not to take you much time on this. Already, this thing is there. The only point which I wanted to focus on, the first point, that gene flow on the natural hybridization. So this already I told you that weed is a rich source of many of the resistance, source of resistance. So and this kind of, because here we have a biotechnologist in our institute and the breeder also. So we are most of the germ plasm collections and the screening we are focusing on, so to develop a any kind of resistance to related to whether it's a weed or insect or the disease. So that sort of study is also required in the area of weed management program. There, then also your thinking will be in a better way. So already at this now we talk about the modeling in the weed management. This modeling issue is also very much important, and I don't find any place where the lot of work is being carried out for the use of modeling related to weed management. Though many of the institutions and most of the scientists I know who has done a lot of good work on the area of modeling, whether it's related to the climate and the other parameters. But related to the weed management, there is no successful model which has come out at the farmers field, and which has been used. So again, for the precision weed management program, this approach is very much important, modeling in the weed management. Precision weed management, which is a sensor-based selective herbicide technology. So this sort of technique, which involves the convolutional neutral network and the machine learning and deep learning techniques. So these sort of techniques are required for the sensor-based selective herbicide application technique program. Then ICT, already I have told about the remote sensing and the GIS use, and apps for the weed management also needs to be in a more better way. I have seen some of the apps, Android apps is being developed for the weed management, but again, the many of the questions are unattended in that apps. So that also needs to be incorporated, and farmers should be told and educated in a more better way and a more easier way, because the identification, I have seen the identification of weeds also is such an area where the most of the scientists, because we are not having a much qualified taxonomist in the country. So this is also a major concern. But with the help of apps and the ICT applications, we can come out with the identification technique, and once we are through with the identification, then only we can have an answer of many of the management aspects. And climate change related to weed management program is also very much important. And as we have seen the distribution of weeds in the climate change, what we are seeing that the most of the crop plant is C3 and the most of the weeds are C4. So in this situation, the C4 will be more beneficial when we are predicting that our carbon dioxide concentration will be higher. So in that situation, we have to be more cautious and dealing with program in a more better way. So such sort of this thing is there. Rising carbon dioxide concentration and temperature will affect the different way. These are the area where the rainfall frequency and adverse effect of take, retention, activity of soil applied herbicide will be affected. Then the increasing rainfall would lead to additional weed pressure. This is also a issue. So all sort of different scenarios are there. So we have to be more focused way that under the heavy rainfall area and where the rainfall is less, suppose in the Bharuch district, or there are certain pockets of Gujarat where the unpredicted droughts are there. So there the competition between crop and some weeds will be different. So there how the crop weed competition study will be there. So those sort of study needs to be taken care. And same case under the climate change, herbicide efficacy will also be much affected. So how the environmental factors such as carbon dioxide, light temperature, relative humidity play an important role when we talk about the uptake, translocation, and different activity herbicide. So these are the issues. When we talk about the conservation, because the conservation agriculture is the area where we are getting a good result of controlling weeds. So this is the area where we can have a use of good machines. The happy seeder, turbo seeder, these are the two good machines which are mostly in the light soil, Punjab and Haryana. The farmers are using, and we have seen a good result of using these machines where the fields are not being plowed, but just simply after harvesting, you just use this kind of machine, and definitely the good results are there. Only problem with this kind of conservation agriculture is that after a period of 5 or 8 years, we are facing a problem of some perennial weeds. If we talk about the weeds, then we have come out with one project with the help of NSF here at Raipur, and what we are going to have a study with this conservation agriculture program, that what are the pest dynamic relationship. So that also study needs to be taken care. Why? Because we don't have any much answer about the pest dynamics over a period of using a conservation agriculture in the longer term. Capacity building, I told you about how the academic and institutional roles are there. If we talk about the herbicide resistance management program, then definitely for developing any kind of management program, whether it is related to herbicide resistance issue or any kind of, for making a sound weed management program, you need to have a better understanding. The competitive faculty must be there. Technical know of herbicide use, that is also very important. Simply getting a prescription of any herbicide and putting in a wrong way, that also leads to many of the accidents. So that also needs to be taken care. Then there are certain online courses to be explored. That in the era of COVID, we could learn that how online business there. That's what you people have managed to show in the national webinar. Otherwise, I would have come to Navsari and have a pleasure trip to nearby places. So, but this COVID time also, we have explored many of the things, and this is a really good thing, and it will be continued, I think. After COVID also, we may have a sort of interactions and the courses through online, so that is there. And sensitization is also very important. Many of the policymaker and administrator, they are not much aware of the impact of weed in the field situation. We scatteredly we used to have that weed loss is there, something is there, but to make a very sound program and this thing policy, so we have to sensitize these people where the who makes the policy in a better way. Then awareness and this program is very much important, and you know that Parthenium Awareness Week is being celebrated every year. So not only Parthenium, I was discussing to the many of this thing that why we not having a national weed program. We should have a certain list out some 4 or 5 major weeds. Parthenium may not be a problem to suppose example I am giving that Gujarat may be having a problem of other social weed which are giving a lot of ill effect to the society. So we have to make a work out the homework that what are the major this thing weeds. So based on this thing we can have this thing. Already I have told you many things because this was the slide. So in the last, I'll just make you the brief this thing that how systemization of methods is important for dealing with the recent trend in the weed management. So we have to focus on the integrated weed management. Integrated weed management in such a way that you have to incorporate all sort of your management aspect, and started from the quality of seed to the harvesting. Harvesting is also very important technique. When we talk about the herbicide resistance management issue, then in the foreign country, I have seen in the literature that how the harvest weed seed control is there. Many of the in Indian condition we will never talk about, we never thought of that such SWSC program is also needed. So there they have a certain this thing narrow window burning chaff cart towed behind the combine harvester, so that they can collect the weed seed during the harvesting time itself. So if we manage harvesting time also in such a way, there where weed seed bank will be minimized. So that sort of program should be there to reduce the number of weed seed going back to the soil. So again, all sort of environmental safety related to the increasing in the crop yield and increasing in the crop production started from the prevention, mechanical, manual, cultural, and the chemical. Already I have told you about the different issues. And the biological, again, it needs to be more strengthened and understand in a more better way. And then only we can have a short solution with the use of mycoherbicides and the bioherbicides. So thank you with all this thing. And any points which are I have missed, you can ask me. I will be happy to answer those queries if you are interested to have an interaction. Thank you very much.
Thank you very much, Dr. Anil Dixit, sir. First of all, I am very thankful to you, sir, for your kind concern to accept our invitation for delivering the guest lecture over here on the virtual platform of our national webinar. Sir, you have covered each and every aspect related to the advances, and I have seen in your lecture that you have given a very nice research thrust for the weed management. That is the weed biology, herbicides, safer low dose synthetic product, precision agriculture, biological control, even extension education, and which are another things, that is food safety and quality, you have also covered. And which are the future technology and the innovations, that is the biotechnology, nanotechnology, novel chemistry, omics, and phenomics, microweaver, robotics, drones. You have covered each and everything, sir, which are very useful for the weed management, sir. And another thing, you have narrated very intelligently, sir. That is, I have seen in your presentation. That is the we are we are that in every year we are awareness program is there for the Parthenium, sir. But you have narrated we have to go for the awareness, that is the national video awareness program, sir. It is your, sir. It says that you are intelligent to how to go for the weed management. We have to look overall that all of the things. Sir, you have also narrated the modeling and weed management, climate change and weed research, conservation agriculture, as well as sensitizing the policy makers and administrator. So you have given a very nice lecture, sir, and it is my immense pleasure that you are here with us on this virtual platform of this national webinar with giving a very nice lecture and innovative ideas for us and our all the participants. So on behalf of the organizing committee, I am highly thankful to you, Dr. Anand Dixit, sir.
It happened because of you, because I have a very good memories with you.
Yes, sir. Yes, sir. I have a very good memory with you in 2010 in the National Weed Surveillance Program, sir.
Yes.
Okay. Okay, sir. Thank you. Thank you very much, sir.
Thank you very much. Namaskar.
Okay, now our next speaker is Dr. R.A. Jat. I request to Dr. Neeraj Kumar to introduce our next speaker, Dr. R.A. Jat.
Thank you, Ridibel, sir. Our next speaker is Dr. Ram A. Jat, sir. I'm very thankful to the Jat, sir, for accepting our invitation for delivering his work in this our webinar. Doctor, I'll give the little information about the Ram A. Jat, sir. Dr. Ram A. Jat currently working as a principal scientist agronomy at ICR Indian Institute of Soil and Water Conservation Research Center, Basar district, Anand, Gujarat. Dr. Jat has 13 years of experience in research, teaching and extension at different national and international organizations. He has worked as an agronomist at the FAI New Delhi during 2006 to 7. And Dr. Jat, sir, also worked in our Navsari Agriculture University, Navsari, from 2008 to 2010. Dr. Jat has been the visiting scientist at the ICRIS at Patancheru 2010 to 12. And Dr. Jat is senior scientist at ICR Directorate of Groundnut Research, Junagadh, from 2012 to 19 before joining to the current institute. He has about a decade experience of working in the field of conservation agriculture in maize, pigeon pea, peanut, wheat, cotton, cowpea, tobacco and castor-based cropping system, and has several publications like papers, book and book chapters, popular articles, folders and abstracts on the conservation agriculture. He has also edited first book on CA conservation agriculture, work over the world in collaboration with the Food and Agriculture Organization, and did extensive review on conservation agriculture published in Advances in Agronomy. So I'm again very thankful for the Jat sir for accepting our invitation. I welcome Jat sir for his presentation. Thank you, sir. Jat sir.
Now you are co-host, Dr. Jat. Ramaudaji.
Yes. Yeah, thank you very much, Dr. Divesh Bhai Patel and the other persons sitting on the dais. Today I'm feeling very happy to talk on this platform. I have worked Dr. Divesh Bhai Patel at NMCA, and I remember him as a very enthusiastic and soft-spoken gentleman. So let me now share my screen. Screen share. So I will deliver a lecture on conservation agriculture for sustainable and climate resilient production systems. The previous speaker has made some remarks about the conservation agriculture. Also, he has mentioned Dr. Anil Dixit sir. So first, why we talk about sustainable systems so much nowadays? We know the paradigm based on the utilization of external inputs of mineral nutrients and chemical pest control, along with intensive tillage for crop production, has been very successful in the sense that is led to the intensification of agriculture to feed the world and avoid the malnutrition outcome. However, we also know that this unprecedented.
Dr. Harijans, please share your screen. Please share your screen.
Okay. Good. Share down. One minute, Dr. Patel.
Okay.
Is it visible now?
Yes.
Visible. Full
Screen sharing is going on.
Yeah, I think now it is visible. Huh?
Just a minute. We are. Yes. It is visible. Now go ahead.
Okay. Thank you, Devesh bhai. So I was saying that why we talk about this sustainable agriculture so much nowadays. So because we know the paradigm based on the utilization of external inputs like these fertilizers, chemicals, along with intensive tillage, has been very successful in the sense that it has led to the intensification of the agriculture to feed the world and avoid the malnutrition outcome. However, this unprecedented success with intensive tillage-based production systems has come with a large environmental and human health costs and has also not brought benefits to all the farm households around the world. Besides, we also know that the soil degradation is a major issue in our country, with 147 million hectares of the land being affected by this. This includes 94 million hectares from water erosion and 9 million hectares from the wind erosion. Therefore, to meet the demand of current population for food, feed, fuel, fiber, and also at the same time to conserve or improve the natural resource base to meet the needs of future generations, the sustainability of production systems is very important. Now, the climate resilient systems, a force need. So we know this has been predicted that in South Asia, the annual average maximum temperature may increase by 1.4 to 1.8 degrees centigrade by 2030 and 2.1 to 2.6 degrees centigrade by 2050. So this the heat stress areas in this densely populated region could increase by 12% in 2030 and 21% by 2050. Besides, even a relatively modest warming of 1.5 to 2 degrees centigrade in South Asia can severely impact the availability and stability of the water resources also. And with this growing reliance of the farmers in India on groundwater to cope with climate-induced drought has led to a rapid decline in the groundwater table also. So in this background, we need the sustainability and climate resilient system of the production systems for the food security of present as well as future generations. And the conservation agriculture is being advocated as sustainable and climate resilient production system worldwide. Now, what is the conservation agriculture? So, according to FAO, conservation agriculture is an approach to managing agro ecosystems for improved and sustained productivity, increased profits, food security while preserving and enhancing the resource base and the environment. So there are three interlinked principles of conservation agriculture. First is continuous no or minimal mechanical soil disturbance. It means no tillage and sowing of the crop seeds directly without the tillage. Then second principle is maintenance of a permanent organic soil mulch cover, especially by crop residues, crops and cover crops. And third principle is diversification of crop species grown in sequence or association through rotations, including a balanced mix of legumes on and no legume crops. So these three principles make the conservation agriculture. Now, next. So the history and origin of the conservation agriculture. The origin of conservation agriculture movement can be traced in 1930s when dust bowls devastated the Midwest USA, and therefore the concept of reduced tillage was introduced. The no-tillage system then entered into the Brazil in the early 70s as a potential remedy to water erosion, and there the anti-system was further refined here, and the principles of soil cover with residues or cover crops and crop rotations associations were added with the principles of no-tillage. Thus, the present concept of conservation came into existence here. Now, in India, the research work on CA started in 1970. The first prototype of zero seed drill was made in 91, which was called as Pantnagar drill. And the improved zero till drill by private manufacturers was made in 97. The Happy Seeder and Turbo Happy Seeder were developed in 2005 and 6 respectively by Punjab Agriculture University, Dasmes Mechanical Works, and Cicero Lab and Land and Water Australia. And these you can see the Happy Seeder. This is presently very popular in the rice wheat system in India, where the sizable around 1.5 million hectare area under zero till wheat is practiced. Now, because of the Happy Seeder also, there remains the problem of this residues during the sowing, because the residues create problem during sowing. So therefore, this super straw management has been recently developed, and this is mounted on the combine harvester. This picks the loose straw, then spreads it finally and spreads over the harvested strip. It helps in the smooth sowing of the next crop with Happy Seeder. Now, the area under conservation agriculture in different regions. So the highest area under conservation agriculture in South America, that is 69.9 million hectare, and that covers 38.7% of the total area under in the globe, and 63.2% of South America is under conservation agriculture. And the next important region is North America, including USA and Canada. That is 63.18 million hectare area. Australia and New Zealand has 22.67 million hectare area under conservation agriculture. Asia has 13.9 million hectare. In the South Asia region, comprising India, Pakistan, Bangladesh, Nepal, these countries are reported to have around 5 million hectare area under conservation agriculture. And India is reported to have around 1.5 million hectare area, mostly under zero till wheat in the rice wheat system. So likewise, in Russia and Ukraine has 5.7 million hectare area, Europe 3.5, Africa 1.5, and the total area under conservation agriculture in the world is around 180 million hectare area, or we can say 12.5% area, cultivated area is under conservation agriculture. Now, we can see the area under conservation agriculture is continuously increasing. in the globe, and by 2015 it has already crossed 180 million hectare area. Now, what are the push factors to CA in major adopting countries, or what were the favorable conditions or incentives which favored the conservation agriculture? Like if you talk about the USA, it was the wind erosion, which was the incentive or the condition which promoted the area under conservation agriculture. In Brazil and South American countries, water erosion was the main reason why the conservation agriculture was promoted there. In Canada, it was the wind erosion and new area under winter wheat. Actually, in the Canada, the winter wheat, the temperatures go very low during the winter, and in conservation agriculture fields, because of the mulch, that the fields this temperature remains somewhat high. That helps the plants. So this motivated them to expand area under conservation agriculture in Canada. In Australia, the water erosion, wind erosion, moisture conservation, and timely sowing, these were the motivating factors. In India, the eco-friendly residue management in rice wheat system and timely sowing of wheat, these were the major motivating factors for this area expansion under zero tillage wheat in the rice wheat system. We know the residue burning is a serious issue in the this northwest India, and therefore it was supposed that this conservation agriculture will help in eco-friendly management of the residues, and also help in timely sowing of the wheat, because the time availability between harvesting of the rice and sowing of wheat is very short. So these were the push factors. Now, CA as a sustainable and climate resilient system. Why it is sustainable and climate resilient? So because the CA provides a multitude of benefits, like CA helps in soil and water conservation. Because in the CA the soil is minimally disturbed and the residues are maintained on the surface, or core crops are grown. So all the time the soil is covered with either residues or with cover crops. So the effect of water and wind erosion is minimal on the soil. Besides, because of the addition of the residues, it favors the soil aggregation. That improves the helps in soil conservation, and because of the these residues are maintained on the soil, the rainwater gets more time to infiltrate into the soil. Then the mulch also helps in water conservation because it reduces evaporation and improves the this organic matter improves the water holding capacity of the soil. Then CA improves soil quality. We know that this crop residues on decomposition releases these various nutrients for plant uptake. Besides, these crop residues provide food for the different soil biota, different organisms in the soil, and thus favors the biological process in the soil. Then CA helps in climate change mitigation through carbon sequestration and reduced emission of the greenhouse gases, and helps in adaptation through the this improved rainwater use efficiency, then avoiding or minimizing the terminal heat stress effect, and then the timely sowing of the crops, and the moderating the soil temperature. Then CA improves input use efficiency, like labor use efficiency, then energy use efficiency, water use efficiency, etc. Then CA gives sustained yield and returns because of the improved soil quality, higher moisture content, timely sowing, etc. And the cost reduction in cost. Then CA maintains interrupted flow of ecosystem services, like it promotes the soil biological activities. Then it increases the infiltration of water into the soil and thus help in aquifer recharge, etc. So now we will discuss these points based on my experience at ICRISAT, at Asia DGR Junagadh, and at this Indian Institute of Soil and Water Conservation Research Center, Vasa. So first, the effect of tillage and this residue management practices on soil aggregation, and we found that this zero tillage was found to have highest total aggregate percent, mean weight diameter, geometric mean diameter as compared to the normal tillage, and also the infiltration rate was also higher under zero tillage. Similarly, among the residue management practices, wheat stubble retention plus Acacia tora mulching. Dr. Anil Dixit was talking about the Acacia tora. So we have used this Acacia tora growing on roadside as a mulch in the wheat crop. Just to make a remark that this Acacia tora is very, the fast growing plant, and completes its duration in 45 to 50 days, and completely over dominates the other vegetation on the landscape. But over a period of time, it has also emerged as a weed in the area, because especially in the this wildlife sanctuaries, because it completely over dominates other vegetation, even grasses. So it reduces the availability of grasses also. So that is the point to keep in mind while promoting this Acacia tora to control this Parthenium. Now, so we found this, total aggregate percentage, then MWBD, GMD higher under with stable and Acacia tora, and also the higher infiltration rate. Dr. Kurothe et al. At Vasa, our center also have found that under no tillage system, this water stable aggregates of size more than 0.25 mm were highest with the no tillage in all the 3 years. Now the annual soil loss, Kurothe et al. They found that this annual soil loss was lesser as compared to the conventional tillage, even though the lowest was with this farming tillage, but no till also performed better than the this conventional tillage as far as annual mean was concerned. And in case of event mean also, this NT was having lesser soil loss as compared to the conventional tillage. Now, we find that this runoff loss under different systems, and it was recorded that the runoff was lowest with zero tillage and residue mulch. Similarly, the peak rate of runoff, which indicates erosive capacity of the runoff, was also the lowest with this system. And the total percent of rainfall lost as runoff was also lowest with the zero tillage residue mulch in both the years of the study. Now the coming to the soil quality improvement, and we found that the available NPK and poo depths was higher with minimum tillage as compared to the conventional tillage, and was also in case of when the residues were retained, it was NPKs were more in peanut based cropping systems of peanut plus cotton and peanut plus pigeon pea intercropping systems at Junagadh. Now we also studied the soil enzymatic activities and SMBC, and the dehydrogenase and alkali phosphatase was activities were highest was with the minimum tillage, and also SMBC as compared to the conventional tillage, and were also higher when residues were retained as compared to the residues removed. Now we also studied the soil temperature at morning and afternoon temperatures, and we found that the morning temperatures were higher with minimum tillage, while the afternoon temperatures were lower with minimum tillage because of the moderating effect of this residues maintained in the minimal tillage, and the lowest mean variation was also with the minimum tillage, which is a desired condition. And similarly with the residues, when residues are retained, the temperature variation is lowest. So that actually this favors the plant growth. This is desirable. And the penetration resistance we studied, and we found that the penetration this resistance was lowest with the minimum tillage and zero tillage compared to the conventional tillage and rotor tillage, especially in the lower depths. Now the porosity, and we found that the minimum tillage and zero tillage was having higher porosity as compared to the conventional tillage and rotor tillage. And also among the residue management practices, residue retention had higher porosity compared when the residues were removed. And then we the yield we found that the yield obtained with minimum tillage was comparable with the conventional tillage and rotor tillage. However, the yield was lower with zero tillage, but the system rate returns were higher with minimum tillage over conventional tillage, even though the highest net returns were with rotor tillage. Similarly, when residues were returned, the higher system net returns were obtained. Now, I have reviewed some of the studies done in India on conservation agriculture, and the different studies have quoted about 6.1% to 46.5% improvement in yield of the different crops, the different cropping systems, and the increase in net returns from 10% to 35.4%. So generally the yield and net returns improve with the duration of the CA study. In medium to long duration, the yield benefits increases. Now the soil organic carbon. Now to see this carbon sequestration potential of the conservation agriculture, and we found that the zero tillage was having highest soil organic carbon in the upper depth, and in the lower depth, minimum tillage and zero tillage was having higher SOC, and even though differences were not significant, and among when the residues were retained, the SOC was higher in 0 to 15 centimeter depth as compared to residues removed. And also in the maize-based system also, we found that this minimum tillage was having improved this SOC in the upper soil depth, while the residue retention improved SOC in both the depths. Now we calculated the diesel consumption in the two systems, and found that the minimum tillage was having much lower diesel consumption as compared to the normal tillage. So this improves the energy use efficiency in the minimum tillage, we can say. And we also calculate the CO2 emission through the use of diesel, and we found the minimum tillage was having much lower CO2 emission as compared to the normal tillage. So this reflects on the climate change mitigation potential of the conservation agriculture. Now, then the adaptation potential of conservation agriculture, we found that the soil moisture was highest at all the stages of peanut with minimum tillage as compared to the conventional tillage in the both the depths, 0 to 15 and 15 to 30 centimeter depth. Now we studied the earthworm population, and we observed that the zero tillage was having highest number of adult and juvenile earthworms as compared to the normal tillage, and also this wheat stubble and mulch was also found to have more number of earthworms as compared to the residues removed. Now, these are the different practices under conservation agriculture done by a team led by me at ICRDGR Junagadh. So, this is the wheat field harvested by combine harvester. Now, this the loose straw is being removed with this vacuum operated this some adjustment. So, this loose straw is collected through this vacuum based machine. Then this is finally cut and stored and used as a fodder for the cattle, while the stubbles remains in the field. So because this is a light black soil and peanut for a crop like peanut, we need some minimum tilled harrow, these small blades between the stubble rows. This was used for making the soil somewhat soft for the sowing of groundnut. Now you can see this sowing of the groundnut in the minimum till field. Then the stubbles are still intact in the field, and this you can see very good crop of peanut in the this field, minimum tillage field in this wheat peanut system. And this we have done on a large area basis, and we have very successfully demonstrated this technology. Even the crop like peanut also can be grown with this, and in even in the light black soils. So we did very many promotional activities also to promote the CA. Like we demonstrated to the group of farmers how this mulching is helpful to reduce the runoff, amount of runoff and the soil aggregates as compared to the bare field condition. The runoff, you can see the runoff is more when the bare field condition is there. Similarly, this soil aggregation from a orchard soil and a clean tilled field, so you can see the soil aggregates are still intact when put in a glass of water. So this is the how this this excessive tillage is destructive to the soil aggregation. Now this field day being organized in a CA field and the different team members. So major challenges, we can see the CA research and development work in India started in 1970s. So it has been 5 decades of research and development efforts. But despite that, we have only around 1.5 million hectare area under zero till weight only. That is not also the full CA. So, what are the major challenges? The first is the tillage mindset. Because of the this over the centuries, the farmers have been tilling the soil. So the mindset has become like this, that the good yields can be obtained only when the soil is tilled. But no. But we have seen, and it has been demonstrated in different systems throughout the world, that good yields can be obtained with zero tillage or minimum tillage also. Uh, so this is the we have the tillage mindset is the one thing. Then weed incidents. Uh, this in CA fields, weed management is a big issue because in our country, still the herbicides use is not so common except in few regions and few cropping systems. And because in the CA, the tillage is avoided, therefore there is over reliance on the herbicides for controlling the weeds. And in India, the weedicide herbicide is not so common as against in the developed countries where there is large acreage under CA. Secondly, we have in India there are more diversified crops and cropping systems as compared to the monocropping systems of the developed countries in Europe and America. So we need the different type of herbicides that are suitable to different intercropping systems and in and different crops in the succession with no harmful effect on the succeeding crops or cross growing association. So that kind of herbicides are either not available or farmers are not aware. And so that is the main reason this weed control is a big issue as far as CA promotion is concerned in India. And the more research work, as Dr. Anil Dixit was also highlighted, there is more need to work on the weed management in conservation agriculture, lack of customized machinery, because we have the different crops, different types of farmers, different land holdings. So we need the customized machinery to suit the different conditions. So those kind of the customized machinery is not much work, or has been done, except in Punjab region, this Ludhiana, some private manufacturers have come forward, and they have made available these machines. But in rest of the country, this work is needed. Then lack of awareness among the farmers, first about this technology, and second that this why this is needed, because this every year a small quantity a thin layer of soil is lost with runoff water, and then the farmers probably are not aware that their precious soil is being lost every year, and how they can prevent this soil loss with conservation agriculture. Then the low land rice in rice feed system, as I already talked, the this most of the area on conservation agriculture in India has been done in the rice feed system. But because of this low land nature of the rice, the full CA has not been, has not come into existence in this rice feed system. And so there is need to replace this lowland rice with the direct seeded rice. Then only the full rice feed system can under CA can come. And our most of the research work also was concentrated in the rice feed system. Very few work has been done outside of late. Now it is picking up. Now the competitive usage of herbicides, the except this right feed system in the IGPs, in India, these residues are used for fodder also, because the animal keeping is an important aspect of Indian agriculture, and we have the integrated type of farming. Unlike countries developed in countries of Europe, and they have separate ranches and different mechanism for the animals and for crops, but we have integrated farming, and our animals depend upon the residues for fodder. So this is also one thing. Then lack of suitable policy support also. In the countries where the sizable areas under CA, that the governments have been very active to formulate the suitable policies. But in India, not that kind of policy environment is there, like on subsidy on the CA machinery, or incentives to the farmers who are practicing CA. So that kind of a suitable policy support is needed in the country. Now the way forward. So what is the way forward to promote CA in India? The first, the efforts should be made for promoting direct seeded rice for adoption of complete CA and rice feed system in the IGPs. Then successful weed management is a big challenge towards outscaling CA. Hence, efforts should be made to develop self-prepared weed puller using artificial intelligence. This kind of some companies like Larsen and Turbo, this in India also, this is also working. This concept is already there, but in near future, this kind of weed pullers may come into existence, and they will be of great help for weed management in CA fields. Then achieving satisfactory plant stand is vital for success of CA. And emphasis should be given on development and subsidized supply of suitable zero-till drills, catering the needs of farmers of different categories. Then a mechanism should be established to geotag CA fields, so that farmers may be benefited through carbon credits and ecological services. So that will really motivate the farmers to adopt CA. Then outside this IGP, CA is still a buzzword with many state agriculture universities having no proper research and development agenda to promote CA in their domain areas. Hence, national policies should be formulated to promote CA mission modes. Now the universities should come forward, to include CA in their this curriculum, also in their research and development agenda, except few universities like Punjab and in some north other HAU. These universities are doing a lot of work, but other universities also need to come forward, and they should include CA proactively in their research agenda and also include in their curriculum. Many researchers are working in isolation on CA. Hence, frequent CA specific seminars, symposia, webinars should be organized at regional, national, and transboundary level to exchange ideas and research findings. Then extension mechanism should be strengthened so that technologies developed reach farmers field as soon as possible. Participatory technology development involving farmers from the very beginning is essential for development and fast adoption of the technology. Yeah, so during the initial years, minimum tillage should be allowed. In the principles of CA, we only there no tillage is allowed, means no tillage at all. But this coming from conventional tillage to zero tillage all of a sudden, there are a lot of management related problems, and this come especially weed management and satisfactory plant stand. So initially this minimum tillage should be allowed provided that the residues remain on the soil. Some like a minimum tillage, strip tillage, like or tillage between the rows of stubbles should be allowed, especially during the initial years, and particularly in crops like peanut, root crops, and other transplanted crops in these heavy textured soils. Once the soil quality improves with continuous residue retention, then this zero tillage may be followed. So this should be done. Some flexibility in approach is also required. Now the conservation agriculture has conclusion. So we can see the conservation agriculture has great potential to sustain the production systems through positive effects on soil and water conservation and better soil quality. CA contributes in climate change mitigation through carbon sequestration, reduce greenhouse gas emission, and imparts resilience to the systems through better soil quality, higher moisture content, etc. Then CA gives sustained high yields and rate returns besides supporting ecosystem services. So thank you very much. Now I would like to have as many as possible questions because this is relatively a new topic. So Dr. Patel.
Yes, Ramavtarji.
Yeah.
Here we can see the chats in which so many participants say that your presentation is very nice. Okay.
Thank you very much.
I'm highly thankful to you on behalf of organizing committee. Today you have delivered a very nice and informative lecture regarding the conservation agriculture, and you are the one of the most and very that is you are the only one person I can say who is working in the conservation agriculture in Gujarat. So it is our we are very lucky that you are here with us. You have given a very nice lecture. Particularly, I have seen from your lecture you have given a that is how much area under the conservation agriculture in our country and globe. You have very nicely narrated, You have also given the different tillage and residue management. How can we done it? Then different in conservation agriculture in different cropping system, as well as major challenges to promote conservation agriculture in India, particularly that is you have discussed on the tillage, weed incidence, lack of customized machinery, lack of awareness, low land rice, in particularly rice weed system, competitive use of the residues, lack of suitable policy supports. All these things you have narrated very nicely, and last, that is, you have given a very that is how can we promote the conservation agriculture in India. So on behalf of organizing committee, I am highly thankful to you to accept our invitation to deliver the lecture over here in the virtual platform of our this is national webinar, and I am highly thankful to you, Dr. Ramavatar ji, and I have a very great memory with you in our Navsari Agriculture University, Dr. Ramavatar ji. So again, I am highly thankful to you.
Thank you, Dr. Patel Saab. Thank you very much for giving this opportunity to me to talk today. So thank you, you and all the organizing team. Thank you very much.
Thanks a lot. Now all the participants, now a rapid fire round over here in our webinar. So the next lecture is given by Dr. Tushar Patel. I invite Dr. Neeraj Kumar to introduce Dr. Tushar Patel.
Thank you, D.D. Patel sir. Our next speaker is Dr. Tushar Patel. Dr. Tushar Patel is our colleague in College of Agriculture, Bharuch, and Dr. Tushar Patel is the person, whenever we conduct any program, the few persons always behind that successful program, and Dr. Tushar Patel is the person who is supporting, and we can say any program we could not complete without the help of the Tushar Patel. And Tushar Patel is such a dedicated person toward the work, and I welcome Tushar Patel. So I'm going to read the little biodata about the Tushar Patel. Dr. Tushar Patel completed MSc in Agronomy in 1983, and in the completed PhD in the Agronomy also, and joined at Navsari Agriculture University in 2013, and he has the 5 years, more than 5-year experience. And under the guidance of the Dr. Tushar Patel, 5 students completed MSc so far. Dr. Tushar Patel got the Chancellor Medal from the Navsari Agriculture University, and second best article award, Jal Jeevan magazine, for his contribution toward the economical work. He got this award. And Dr. Tushar Patel is having the 5 recommendations toward the farming community, 1 recommendation for the scientific community. Dr. Tushar Patel is having the 22 research papers, 12 books, chapters, 25 popular articles, 2 leaflet and bulletins. And Dr. Tushar Patel is currently working on the field of the weed management and this crop production. So I'm very thankful Dr. Tushar Patel for his presentation. I welcome again Dr. Tushar Patel for his presentation. Thank you.
Am I audible?
Yes.
Okay, thank you, Dr. D.D. Patel sir, Dr. Neeraj Kumar sir, for my nice introductions. I can see that this is a very high time, and I can see more than 100 participants still bear with us that across the SAUs, across our country. My today's topic is regarding weed management, that particularly with non-chemical weed management options in reference to sustainable agricultures. I know that the participants are come across the nations, and they are very much learned persons, though they might have know very much about this non-chemical weed management practices. However, whatever I have reviewed and I have studied from my experiment, I have just highlighted my my reviews and my experience in these presentations. Before going to depth in my presentations, Dr. Anil Dixit sir as well as Dr. R.M. Jha sir already narrated so many points regarding non-chemical weed management practices. So I just skip that all points. I just simply highlight those points that is very much important for sustainable agriculture point of view. As you all know that Indian agriculture science, the plants are classified into two categories. The plants which are useful with the human interest, that is used for human consumptions with the welfare of human, they are recognized as crops. And those plants, they are found unwanted, they are found useless, or sometimes it may be interfere with the human welfare, that are recognized as weeds. Farmers have been struggle with the presence of weeds since the beginning of the agricultures. Weeds normally suck the moisture from the soil. It steals the nutrients from the soils. It blocks the sunlight from the sky. So in that way, it competes with our agriculture crops. Year after years, we are fighting with the weeds. However, no sooner we pull the weeds, now and again, they sprouts behind us. So this is the time where we have to discuss, we have to think the technology that can more compatible with the management of the weeds, so we can shift our vegetation in desired directions with optimum productions of the crops. Okay. So when we consider the total annual losses of the agriculture from the various pests, wheat rank first. So on an average, it can cause at least 45% of the agriculture crop productions. And the potential, if we consider the potential of the weeds in the losses cost, that is reached up to 74%. And that is almost much higher than any other pest that observed in agriculture, that is insect, disease and others. So we have to think more precisely to manage or destruct the weeds in agriculture to sustain the agriculture productivities. With the inventions of the herbicides and other chemicals, we think that now we are able to manage the weeds somehow. And as you know that after independence, our strategy, our goal is directly associated with the self-sufficiency in agriculture. And with the introductions of green revolutions, with the use of fertilizer, chemicals, and other agro pesticides, we are able to achieve the status of the self-sufficiency. And right now, we have also produced some surplus food materials. But at what cost? Indiscriminate use of the chemicals, herbicides, and pesticides, we are facing so many problems, and that are listed here, that impact on human health, that contaminate the soils, that contaminate the environment, that also affect on the soil microflora and fauna, surface water as well as groundwater, both are contaminated with because of the excess use of the these herbicides. That also contaminate our food commodities that already enter in our food chains. Ultimately, we are suffer very badly. And you might have known that the many states of our country where the excess amount of use of the agrochemicals, the cancer is become dominating issues, particularly in northern state of the Indias. It also contaminate the air, non-target organisms. So ultimately, of course, we have our agrochemicals, but we are polluting our natural resources, and we are facing very serious issues regarding the agriculture productions and productivities. So look at the scenario of the weed management techniques, what we have available. After primitive agricultures, we have some hand tools. After advancements of the science and technology, we are able to discover the herbicides, and nowadays we are able to suppress the weeds somehow. But eventually, this technology is still not found sufficient to sustain the agriculture productions and productivities. When we talk about the past, with the availability of the resources, particularly manual labors, we are able to suppress the weeds somehow. And with the availability of some hand tools, we are able to suppress the weeds significantly. But under unavailable of the labors and under some circumstances, it is not possible to suppress the weeds somehow. So under that circumstances, farmers need to compromise with their agriculture productions, and competition become exist. Beside, with the presence of the weeds, some of the plants that maybe harbor the pests and diseases. And our prime goal is to suppress the weeds by adopting some weed control practices. So eventually some advanced technologies we have, and at presently we have a herbicide. With the advancement of the herbicide technology, we have a number of herbicides nowadays available, and we are able to significantly minimize the incidence of weeds in agricultures. But because of the continuous and monotonous applications of the herbicides, we are facing the problems of weed resistancy, and it become dominance nowadays. So under that circumstances, we are searching for alternate options that can sustain the agriculture production beside maintain the biodiversity of the planets. So what will be the future options? The future option is only one, that integrated weed management systems that rather to dominate on the chemicals, it should be rely on the non-chemical approaches of the weed management. Now the question may be arise in our mind that integrated systems, we are already talking about the integrated systems. Of course, we are talking about the integrated systems, but whatever the integrated system we are using now, that is work linearly rather to cyclic way. So we have to call up, we have to combine the whatever the available resources, whatever the available technology we have in such a way that not only satisfy the weed management requirement, however it also satisfy other agronomical requirements. So we have to think cyclic way about the integrated weed management systems by minimize the use of the chemicals and more dependency on the non-chemical weed management approaches. So how it can be achieved? So when we talk about the integrated weed management systems, we have basically three objectives emerge as a most prior way. First one, that is don't let weed emerge. So as you know that we have a prolific seed producers. When it becomes established, it produces seeds. Thousands and millions of seeds are stored in rhizosphere that become again create the problems for more than 7 to 8 years. So on that circumstances, it is more advisable to destroy the weeds at the time of emergence or before the emergence. Second, don't let establish the developed weeds, or don't let escape the weeds with produce seeds. As you all know that once the favorable conditions are exist, under that circumstances, weeds are easily come out from the soil surface. So as much as possible, don't try to establish weeds on our field conditions. Somehow by adopting whatever the practices we have to suppress the development of the weeds. And once it become established, care should be taken that it's failed to produce the seeds. We have to eradicate our weeds from our fields without it produce the seeds. So these are the basic objective of the weed management practices. And to achieve these objectives, we have 4 major principles that involve in weed management practices. So whatever the techniques and technology we have, it should be eco-friendly. We are all aware about the ill effect of the herbicides. So we have to choose the technology that has less harm or no harm to the environments. Second, that is to break the survival mechanism of the weeds in soils. As you all know that weeds have unique characteristics. They are very well survive under adverse climatic conditions. They are very well decimate. They have a very good mechanism to disseminate from one place to another place. So we have to break their survival mechanism as well as dissemination mechanisms, and that is only possible by knowing the habits and ecology of that particular weed species. Easily acceptable by the progressive farmers. Of course, number of technology discussed by the Anil Dixit sirs, but it is very much difficult to assess by the common people, by the farmers. So we have to suggest that technology that become easily accepted by the common people or progressive farmers for maximum adaptations of the particular technology. And last one, that is regarding the crop husbandry management practices. Right now, whatever the weed management tactics we have, that is dominated by the agrochemicals. And we are less emphasized on the crop husbandry management practices. So we have to include a crop management or crop husbandry practices to manage the weeds somehow. And that are some of the practices: crop rotation, mulchings, time of sowing, and many other practices that we're going to discuss on eventual in later on slides. So some of the point I have isolated from the reviews that is very much essential that we have to keep in mind for successful management of the weeds. And first, that is 3N strategies. As 3N, That is very much important in weed management concept, and that is native, nature, and neighbors. As you all know that weeds were exist here before us, and it will be exist here after us. So why we are always try to declare a war against the weeds? It is totally unwinnable war. We have to divert our lookout towards the weeds. We have to think about the coexistence with the weeds. Actually, weeds are not enemy. Weeds are our friends, and that is a nature, native, and neighbor of the humankind. So we have to accept its coexistence rather to consider it as an enemy. So whatever the techniques we have suggest, that totally considering to manage the weeds rather to control it, and that can be possible by for as practices, that is regarding scouting, sanitization, selections of management time, and systemic weed management practices. As you all know that scouting is very much essentials. Before during the primitive agriculture, even before independence, peoples are wandering in the fields and find out what whenever the unwanted materials are found, observed, and adopt the management practices accordingly. So scouting is very much essential. Sanitization, of course, dear participants, farmers, even we peoples are more emphasized to control the weeds during the seasons when the crops are there. But what about the off-season weed management techniques? We are least concerned with the off-season weed managements. So we have to remove the weeds as and when it observes. At least we have to suppress the load of the seed bank of the weeds in rhizospheres. So sanitation is very much important. After knowing the management practices, we have to opt the base management practices for our locality, for the considerations of the crop, by considerations of the management practices we have. So we have to choose most appropriate weed management practices that not only satisfy the need of the weed management, besides it's also economically viable, and it is also suitable that satisfy the other economical requirement of the crops. And last one, systemic weed management practices. Of course, number of weed management practices we have, but we have to choose most suitable, most economically feasible weed management practices for our area, for our crops. Before we discuss regarding the non-chemical weed management practices, I just want to highlight the most important points of weed management. That is regarding crop weed competitions. As you all know that each and every crop having different ability of the competitions with the crops and weeds. So under that circumstances, in generally, 1/3 period of the any crop is recognized as the most critical period of the crop weed competitions. During that period, if you allow to establish the weeds, it will harm our crops very badly. So we have to take care of 1/3 period of the crop weed period of the any crops lifespan is considered as a crop weed competitions, and demilize or try to reduce or try to combat the weeds during that 1/3 periods. And for that, number of non-chemical weed management practices we have. And these weed management practices are preventive, that cultural method, mechanical methods. Of course, chemical is there, but I am talking about the non-chemical weed management practices, so it is not considered here. Burning and framing, of course, it is not so much practical in our country. However, it is more approach in Western countries. Biological approaches of the weed management, that has also become taking some momentum in Madhya Pradesh, and in where the Parthian history forest is become dominated. And botanicals, of course, nowadays people are searching for the botanicals. Number of botanicals are available in market, and that is used as pesticides. And last one is utilizations. So these are some of the non-chemical weed management practices. I will discuss one by one these weed management concepts. So first one is the prevention. Prevention is always better than cure. As you all know that prevention techniques does not offer to eradicate the established weeds, but however, it can prevent to establish the weeds from new area. It can prevent the disseminations of the weeds from infested area to new area. So prevention is very much essential, and this is actually less costly and most easiest way to combat the weeds rather to weed control and eradications. Know that clean seeds and seedlings are very much important to reduce the or to minimize the weed incidence during the succeeding during the crop periods. For example, farmers are normally store the previous harvested commodities for next season sowing crops, particularly in wheat crops. It, as per the one review published by the director of wheat research, 1 kg of the wheat seeds having 2 to 3 gram of the phalaris minor seed. It means that for 1 hectare seeds of the wheat, it having more than 5 lakh seeds of the phalaris minors. So under that circumstances, we are not actually showing the wheat seeds. Besides, we are showing huge amount of phalaris minor seeds along with the crop seeds. So always try to use a clean seeds and seedling for transplanting or for sowing purpose. Second most important point is that the wheat always use well rotated, well decomposed FYM as a manure. You know that the basic objective for adding up this manure to improve the fertility of the soil. However, with the purpose to early improving the soil fertility, farmers are using undecomposed, unrotated FIM in our fields. However, under that circumstances, a huge amount of wheat seeds are also dumped with this FIM, and that become create the problem for succeeding crops. As per one estimation, 1 ton of the FIM having more than 10 lakhs of the viable seeds because of faulty method adopted by the farmer for preparations of the FIM. So always use well decomposed FIM for our agriculture purposes. Clean all the farm machineries and farm animals. You know the disseminations of weed is always there with the farm machineries and farm animals. So whenever you use farm machineries or any animal from infested area to new area, it should be neat and clean. That check the disseminations of the weed seed, weed propagules from one area to another area. Clean the irrigation channels. As you all aware that we are least concerned with the irrigation channels, but it is a huge reservoir. It acts as a huge reservoir of the weed seeds, and it become create the problems whenever these reservoirs or this irrigation channel are used for irrigation purposes. So use always clean the irrigation channels and fence lines. So ultimately we are check the reservoir of the weed seeds. Always clean the farm birds and roadsides. These are some of the preventive weed management practices that is very much effective. If we adopting this technology somehow, definitely it will work 30 to 40% and suppress the weed management, suppress the weed populations. That become very much easy and very much economical comparatively irrigations and control methods. Second, my highlighted point is crop rotations. As you all aware that crop rotation is very simple. It is nothing but the sequential arrangement of crop and fallow and series of development of the different crops on same pieces of land year after years. But the basic purpose behind crop rotation is somewhat differ. Our basic objective behind crop rotation is to improve the soil fertility by maintaining diversity of soil. But at the same time, as you all know that crop rotation is also very much particularly in tobacco crops, it is more advisable to adopt the crops like a sesamum instead of the tobacco monocultures. So it can check the incidence of the orobanchi and other parasitic weeds. Similarly, in case of the striga is very much problematic in sorghum, even in sugarcane, in bajra and maize. So if we are continuous practicing these types of crops, definitely it become problem. The problem become overcome again and again. It become
dear participants, I think there is a internet connectivity is not there with I think Dr. with Tushar Patel. Tushar Patel is I think facing the problem of internet connectivity. Please be with us. Will soon join with us. So Dr. Tushar Patel has given very nice topic and very nicely presented the topic that is given by the for this webinar, that is non-chemical weed management for sustainable agriculture, and he has nicely given the information that is the unsolved issue of the which are the different unsolved issue of the herbicide. What about the past, present, and what is the future in for the weed management? He has also narrated the 4 principles of the weed management, that is, and also given the 3N for the weed management, that is the nature, native, and neighbor. So we have to exist with the nature rather. Okay, Dr. Tushar Patel is over here with us. Okay, Dr. Tushar Patel. Okay, Dr. Tushar Patel. Your screen is visible.
Now I am audible?
Yeah, you are audible. Now screen is also visible. Please go ahead.
Sorry for disturbance. Actually, I lose my connectivity. Again, I reconnect and shall I continue?
Yes, continue. To be continue.
Okay.
And
Thank you.
Speaker is also ready for over here.
Okay. So here is I'm talking about the crop rotation. So it is very much successful for combat the weeds in as a non-crop remedy, non-crop weed management remedy. Second thing is orientation crop. Dear friends, as you know that east-west direction is recognized as the most benefited orientation for any crops. It become create the shady condition for weeds on the weeds, and ultimately in the absence of lights, weeds are failed to establish or weeds are failed to grow profusely. So under that circumstances, it is advised to grow the crops in east-west direction rather to north-south direction. It can suppress the weed dryment by 30 to 40% comparatively north-south directions. So it is more advisable to establish a crops row in east-west directions. Second thing is that by reducing the row spacings, as you know that the germinations of any crop, light is very much essential. If you narrow down the spacing of the crops, definitely it will minimize the light interceptions by the weeds, and under that circumstances weed become suppressed. Ultimately we can achieve the goal of the weed management. Seed rate, increase the higher seed rate. Similarly, if you use a higher seed rate up to 100 kg of the weed seed, it will minimize the incidence of the raygrass in the weed crops. So seed rate is also, higher seed rate is also found beneficial in terms of the weed management practices. I know the time is limiting factors, so I will go hurriedly with my talk. So these are some another cultural management practices to combat the weeds: mixed cropping as well as smoother croppings and intercropping. As you know that the basic purpose, basic logic behind this mixed cropping, intercropping as well as smoother cropping is what? To check the sunlight to reach on the soil surface, to reach on the weed seeds. Under the absence of the lights, weed seeds are failed to germinate, weed seeds are failed to establish, and definitely we can achieve the goal of the weed management. So these are the some of the basic logic behind this. Some of the crop like groundnut, soybeans, cowpea, and many others, they are successfully work as a smoother crops. Similarly, in the mixed cropping systems, so many crops are there. Maize that is associated with the cowpea, that is associated with the soybean, pigeon pea that is associated with the castors. So these are some of the good successful examples of the mixed cropping that not only satisfy the soil fertility goal, but at the same time it can also suppress the weed seeds significantly. Now the irrigations. Of course, irrigation management is also play a very crucial and an important role in suppressing the weeds. In that way, flooding, you know that the arable condition is very much essential. In most of the muddy conditions or unarabic conditions, weeds are failed to germinate. However, opposite to that, if we are continuous and frequent irrigations are applied on the field, any field, it's more provide the more favorable and congenial environment for the establishment for and the flourish of the weeds. So it is advised to adopt the micro irrigations or alternate furrow system of irrigations to combat the weeds, and that is very much essential. Under micro irrigation systems, we are only wet a part of the land area, and so weeds are always developed in the presence of the moistures. Whenever it found the moisture, it becomes germinates. And under drip irrigation systems, we are only covered the small area for irrigation purposes, and whatever the weeds are emerge out, it can easily manage comparatively flood irrigation management practices. Now mulching, this is my personal and my own experience regarding the mulches. Mulching is a very common technique. It is nothing but the covering of the soil surface by artificial means. It may be by through plastic or it may be through by any organic means. So you might have seen the photographs here. Both here we were used sugarcane trash as a mulching materials, and by this sugarcane trash we are able to suppress the 60 to 70% of the weed species in banana crops. However, in same crops we were also use the polythene as a black plastic sheet as a mulch, and it's really magical performance of what I have received from the plastic sheets. It is able to suppress the 90% of the weed species because of the polythene mulchings. Of course, 10% is still there, but the wearing and tearing is little bit issue with the plastic mulch. However, more than 95% weed management can be possible with the adaptations of this plastic mulch. Under both the systems, that not only satisfy the goal of the weed management, but at the same time, it can also save our natural resources. Under both the system in plastic mulch, it is observed that it can save 40% of the water, while in straw mulch, in banana particularly, it can save 30 to 35% of the waters. Similarly, it can also save 20 to 30% of the fertilizer requirements. So ultimately, we are towards the sustainable agriculture. Here you might have observed the sugarcane trash mulch in cucurbitaceae. Yes, it have also a significant result I have obtained from this experiment also, even in marigold, even in sugarcane itself. So in general, the mulching techniques can suppress the weeds by 60 to 90%, depends upon the what types of material you have opt for mulchings. Of course, land preparations. You know that puddlings, it is nothing but the simple techniques. Run the heavy machineries on the muddy conditions, and whatever the existing weeds are there, it become buried, or whatever the weed seeds are there, it become buried in the muddy conditions, and it's a fail to germinate or it's fail to establish. So these types of management practices also suitable for rice cultivations, summer fallowing, and raised seedbed sowings. Distinguished participants, summer fallowing is very old recommendations that not only combat the insect pest, however, it is also found significant to reduce the incidence of the weeds. You know, exposure of the weeds on hot summer, it become either chewed by the birds, it can be either bite by the animals, or it can be because of the directly exposed to the sunlight, it become destroyed in the presence of the heats. So these are the one of the significant weed management options as a non-chemical weed management practices. Similarly, during the summer season, it is more advisable to sow the crops in row rather than on ridges. The reason is that during summer seasons, we have to apply the irrigation to further grow and establishment of the crops. So that only in furrow, and whatever the weeds are there, it is established and flourish in furrow. So it is somewhat more easier to destroy the weeds in furrow rather to an entire area. dear participants, night cultivation, that is of course that is the one of the new research area that having also significant influence on the wheat seeds germinations. So particularly in that case, as you all know, that light is very much essential for establishment of the crops and weeds. So under absence of the red lights, weeds are failed to germinate. And during the, if we are cultivating our soil during the day times, ample amount of light resources are available. So it is advised to till our soils during the nights. Under this system, what happens? During the night times, very little amount of lights are there, that is artificial lights, and under that circumstances we can able to minimize the weed incidence, and that is reported by some foreign scientists. How particularly in amaranthus species and echinoclea species, night tilling is very much efficient. It can suppress the incidence of echinoclea species and amaranthus species by 70%. Still some research is required under that with the night tillage cultivations. This is also one of the experiment that is regarding the impact of different tillage practices on the distribution patterns of the weeds. As you in the first figure, you might have saw that after harvest, this is the distributions of the weed seeds and rhizospheres. And what happened after the plowing of that particular field? It is here almost up to 30 to 40 centimeter depth. It distributed the seeds of the weeds. While in case of the cultivator, the penetration is up to 10 to 12 centimeters only. So the whatever the weed seeds are there on the surface of soil, it become distributed up to 10 to 12 centimeter soils. And in case of the rotavator, as you all aware that rotavators are only penetrate up to 4 to 5 centimeters. So there is little disturbance or exists. So under that circumstances, plowing is found most appropriate methods to combat the weeds for succeeding crops, comparatively cultivar and rotavators. However, in case of rotavators, majority of the weed seeds that found on the upper top soil of the soil, that is almost 61% of the, or sorry, 71% of the weed seeds observed in upper top of the soils. Whenever it observed any congenial environment, it become established and flourished just like anything. Under that circumstances, it is advised to opt plowing or cultivations for compacting the weeds under non-chemical weed management practices. Yeah, it is a very old practice, hand weeding and hand tools. You know that it is a very effective and very much available, very much popular technology amongst the farmers. Hand pulling, however, though it is very much effective, it is a monotonous, it is very cumbersome. So farmers are choosing herbicide instead of hand weeding and hand tools. However,
You are not audible.
Of course. Now I think I am audible.
Yes.
Okay, because in this hand weeding and this technology, we can provide huge huge employment for the women laborers. Still now 70% of the women laborers in agriculture are engaged in hand weeding operations. So we are not only satisfy the weed management requirement, at the same time with the hand weeding or by hand toolings, we are providing employment to many people. And interculturing, you know that under existing field condition in standing crops, interculturing also play a very crucial and important role to demolish the weeds directly. By using the blade, harrow and other tillage implements, we are able to demolish the weeds between the two rows of the crops. However, one limitation is there. It is possible to remove the weeds from the rows, but what about the row, what about the weed that is observed beside the weeds? So of course, under that circumstances, it is advised to go with the interculturing and hand weeding techniques combinedly. With these techniques, whatever the weeds that exist within the row, that can demolish by using the cultivation operations, and whatever the weeds that is adjoining, that is neighbor with our crop plants, that can be removed by hand weeding practice. And with these combinations of the hand weedings and this interculturing operations, we can minimize the load of the labor requirements up to 60%. So again, that become very much importance in these aspects. And this is, I think this is one of my favorite techniques as a non-chemical weed management practices, that is the stale seedbed techniques. The basic principle behind this stale seedbed technique is what? First, raise the weeds. That means we have to develop the seedbed for the weeds, allow to establish the weeds and destroy the weeds and eventually sow the crops. Let me see the diagram of stale seedbed techniques. So here, what happens? Before the sowing of the main crops, before the 15 days of the sowing of the main crops, we have to prepare the seed bed, that is called as a fall seed beds, because we are preparing the seed bed for weeds, and that's why it is considered as a fall seed beds. And light irrigation is given to that seed beds in the presence of light, in the presence of water. Whatever the weeds that is available on the surface of the soil, it become established within a 10 to 15 days by adopting some light tillage operations like light harrowing. We can demolish the surface weed seed. In that way, we can able to suppress the weed seed bank up to 60% before the sowing of the main crops. So we can check the initial crop weed competitions that actually exist under the absence of the stale seedbed techniques. Similarly, for repetitions of these stale seedbed techniques, and it's take on at least 1 month before the sowing of the main crops. So what happens? We have to prepare 30 days before the seed bed, and again, given the light irrigations, weeds are come out, it should be removed by using some some harrowing type interculturing operations. Again, we have to irrigate the crops. Again, we have to remove the weeds. With this two times harrowings, we are devastating the huge amount of the seeds, weed seeds from the rhizospheres, and we provide somewhat more favorable atmosphere for our succeeding crops. So by these methods, we can able to minimize the weeds at least for short period of time, at least for our succeeding crop by 60 to 70%. Soil solarizations, of course, it is a very good technique. It is nothing but the hydrothermal techniques of the weed management. By utilizing some of the sunlight, we can able to suppress, or we can able to manage the weeds. Under that circumstances, the things are practiced during the month of the summer, particularly in the month of April, May. With this soil solarizations, we are able to devastate the weeds up to 40 to 60%. Particularly, that is more efficient in a control area like a greenhouse, like a nursery. You might have observed that here the nursery area is covered with the transparent plastic sheets after wetting of the soils. So whatever the sunlight is there, it becomes trapped within that plastic mulch, and ultimately it increases the soil temperature by 10 to 12 degrees, and that will kill most of the weed seeds, and as well as the other disease causing organisms and other propagators of the pest. Well, so ultimately, we can achieve the goal of the weed management. These are some of the photographs you might have observed here. This is the soil solarized plot of the soybean. However, in unsolarized plot, you might have profuse growth of the unwanted vegetation. Similarly, here, this is the brinjal nursery. It's very rare to observe any unwanted vegetation. Similarly, here also, the tomato nursery, again, it is become so efficient. However, some perennial weeds like Cyperus rotundus and Celadon dactylon, it become less effective against, it become less damage because of this soil solarization techniques. Burning and flaming, of course, it is not so much popular in India. However, it is also one of the options that is recognized as a non-chemical weed management practices. Bioagent and botanicals. Distinguished participants, Jabalpur, our director of weed research, done very nice job on this bioagents. They have released the this Zygochroma bicolor beetle for Parthenum hysterophora. Similarly, this one, and similarly, this is Neochitina brucci. This is very much effective. this is very much effective to combat the water hyacinth. As you know that most of the Indian water body are contaminated with this water hyacinth, and it is not possible to use chemical methods to devastate water hyacinth. So this Neochitana brichi become very much a successful bioagent to destroy the issues of the water hyacinth. Similarly, lots of the botanicals are available, lots of the botanical reviews are available that can be used, that have some herbicidal property like a vinegar, like a citrus, or a parthenium having a parthenin, and that is also suitable to destroy some of the monocot weeds. Sorghum, as you all know that sorghum having the HCN and that having some herbicidal property. Neem as a directine, that having also still some research is required under that circumstances, but this is the hope of the non-chemical weed management practices. And allelopathy, as you know that each and every plant having the allelopathy impacts. Allelopathy, simple sense, it's having their impact on neighboring plants. So many crops having that types of efficiency to destroy or to suppress the neighboring plants. As Dr. Anil Dixit sir told that rice plant having that types of capacity and ability to suppress the neighboring plants. So we have to identify that types of allelopathy potential crops that become more competitive with the weeds, and we can achieve the goal of the non-chemical weed management practices. Weeder geese, of course, this is also a concept of the Western countries particularly that is more suitable to cotton crops, tobacco crops, potato, onion, sugarcane, strawberry, fruit crops with some conditions, particularly in strawberry crops. Of course, it feeds on the ripe strawberry, so we have to back our weeder geese from the field, strawberry field, before it bears the fruits. Similarly, in cotton crops, they are not preferred to feed on the cotton crops. They are normally feeds on the very young and delicate seedlings of the weeds. So under that circumstances, it is advisable. Similarly, in tobacco also, weeder geese are also suitable. So under conditionally approach, we can also use this weeder geese as a non-chemical approach of weed management. So from my topic, I conclude that weeds that cause significant losses in agriculture by compacting with the main crops for nutrients and other resources, and also act as an alternative host for disease and pest. The use of the chemical herbicide has many ill effects on environment, as I already narrated that. Therefore, various non-chemical and eco-friendly practices which are equally effective may be used for the weed management. However, effectiveness of that particular weed management practices require extension planning and preventive measures coupled with the various cultural and physical methods of weed management. Of course, monitoring of the weeds growth stage is also very crucial to determine the ideal cultivation times. Besides this, biocontrol and understanding of the agrochemicals may help the future concept of the weed management. So this is all about the non-chemical weed management practices. I hope you might have received some knowledge from these presentations.
Thank you very much, Dr. Tushar Patel. You have very nicely narrated each and everything regarding the whatever the topic given to you, that is non-chemical weed management for sustainable agriculture. You have given the different techniques, that is the cultural method, crop rotation, as well as mix, smoother intercropping. Very nicely give the information regarding this, and also you have narrated some important points, that is the mulching and land preparation. Also, you have given a very nice thing, that is the night tillage is for Echinocloa colon species. That is the newer thing which will be useful for us for the research purpose also. Stale seed bed techniques, soil solarization, bioagents and allelopathy, and another that is last one, that is the weeder geese. Okay, this is the newer idea for us to go for the research in our area. So you have given a very nice talk regarding this, and I am highly thankful to, even though you are a part of my organizing committee, I am highly thankful to you, Dr. Tushar Patel. Now our next speaker and last speaker of the third day of this webinar, Dr. N.N. Gudade. He is working as assistant professor in NM College of Agriculture, Navsari Agriculture University, Navsari. He has completed his BSc and MSc from Dr. PDKV Akola, Maharashtra, and PhD from MBK, and he has deputed as assistant professor in 2011 in Navsari Agriculture University. His specialization is, and he has guided 9 MSc students, and he has also worked on nanotechnology also. And he has awarded with 4R nutrient stewardship award in 2018. So now I request to Dr. Nitin Guradeji, please go for your lecture. Now platform is yours. Dr. Nitinji, please unmute yourself.
Now am I audible now?
Yes, you are audible.
Okay. Thank you very much, Dr. Deptt Patel sir and whole organizing committee for giving this opportunity to share my knowledge or my learning, whatever I have learned from since last 8 to 10 years. So I have chosen this topic, climate resilient technique for enhancing pulses productivity. So especially I am going to talk about the cool season pulses and especially chickpea, because chickpea is a cool season pulse crop which is very vulnerable to climate, and we can see now we are able to see that the day by day the data is showing the climate is warming slightly. Another thing is that day by day what is happening is that the winter is shifting towards November or December, especially in terms of chickpea, because we want to sow the chickpea crop in the month of October, after 15th October. But the arrival of winter is very late now. At the same time, it is ceasing very early. Means the window for chickpea sowing is very narrow. Means once the crop is setting very late, after that the crop is getting very less time to maturate. So we are fetching very lesser amount of chickpea yield because of this. So we have done some of the interventions for this. So let's see what we have done for it. So we can see the various newspaper cuttings. You can see here that why the winter has arrived late. So number of news coming in last 4 to 5 years. The winter is arrived 2 weeks or 3 weeks, 4 weeks, 6 weeks late. So you can see this news cutting of Indian Express. It is showing that the winter has finally set at least 6 weeks later. So again, it is causing a problem to the crops, especially chickpea. Another news you can see, late arrival of winter affects strawberry production. This is the news of 2017. The production of the strawberry has come down by around 33%, as several farmers could not sow the seeds due to late arrival of winter. So you can see it. The number of newspapers are reporting such kind of news. So what is happening in last 25 years? There is sudden rise in the temperature. You are knowing the causes. So you can see in most of the part of the India, you can see the orange or red color. They are showing you the above normal maximum temperature. And this part is showing, you can see this is most of the part. This area is a dryland area. here in MP also, which is Madhya Pradesh is the home of the pulses. Most of the pulses are coming from Madhya Pradesh. We are facing this problem of the late setting of winter, and again you can see the winter is ceasing very early after just in the late January. The crop is getting very less time for the seed setting and the seed filling stage. So what we can do, we should have some intervention through which we can delay the senescence of the chickpea crop. So let's see what we can see again. The causes of the shrinking winter are given here. Even you can experience our sweaters are working not more than 15 days. Sometimes in last couple of years. This year it is quite a good winter, and over last 2 to 3 years winter. You can see number of problems are here. You can see here the El Nino effect. You are knowing, then weaker and lower number of western disturbances which are giving snowfall to India, and because of that the cold waves are coming to the central and south India. So what we can do is that we should have some intervention or some technology through which we can extend the lifespan of the pulses, especially in terms of chickpea, on which we have done our work. Again, one more problem is there, the terminal heat stress. I think most of you have heard the terminal heat stress in terms of wheat in North India. But we have seen this terminal heat stress problem in chickpea also, and in which the crop is getting very lesser time for the seed filling at the pod filling stage. What we can do, what can be done so that we can extend the lifespan of the chickpea because of this the extreme rise in temperature due to global warming. Again, you can see in this slide that the number of crops are shown here. The projected change in the crop yield in 2035 and 2065 and 2100. So you can see the minimum and maximum decrease decrease in the yield. The problem is to the pulses. You can see here, pigeon pea is going to face the problem, and among the cool season, it is the chickpea. Chickpea here. Of course, the pigeon pea is extending up to December. That's why we can consider it as a cool season also. Then you see in the 2065 chickpea yield going to be suppressed in 2100. So we have to take certain measures so that we can at least curtail this temporary problem means for 2 to 3 months, at least last 2 months in chickpea. So what we can do, number of measures are suggested in agronomy for management of the pulses. What we can do, number of problems. I'll just read it, but I will go to my topic. After that, tillage management, planting time we can change, sowing direction we can change. Dr. Tushar Patel was talking about this planting direction and method of sowing, and then sowing depth. Sowing depth can also change the scenario. Then plant geometry, optimum seed rate, then seed priming, village levels seed systems, straw mulching, because mulching is having a good role in microclimate management, then nutrient management, water management, improved weed management, plant protection. And then other things what we can do, selection of suitable varieties. Because if you are selecting suitable varieties, short duration varieties, then we can escape from the problem of the climate change. Then adoption of the existing technology for bridging the yield gap. Then pulses cultivation in the rice fallows. We can enhance the rice the pulses yield, because rice fallows in most of the part of the central India and eastern India, we are not cultivating any other crop in the fallows most of the areas because of the less availability of irrigation. So we can use that area. New cropping system we can have, then crop modeling, and then abiotic stress studies, then agro advisory services, and policy support. So you can see in this photograph that the early variety, extra early variety, and normal varieties are grown. And you can see here the early variety are already ready for harvest here. Okay, so these varieties can escape the problem of the climate change. Again, this is early, this is extra early, early variety, and normal variety we can see. And if in this situation the sudden rise in temperature is there, then definitely there will be reduction in the crop yield. So such things can be adopted. Now we'll come to our research, what we have done for it. So we have gone through the literature, and we have selected a chemical, cobalt element. And the specialty of cobalt is that it can delay the senescence of the crop. Okay, so if the senescence is delayed, the life cycle of the crop can be increased. And if the life cycle is increased, we can have sufficient time for the pod filling stage of the chickpea crop. So that's why we have in the first experiment with all the experiments we have done with my MSc students, and year by year we have done modification on our experiment, and we have generated good information out of that. So at very first year we have chosen two chemicals, cobalt sulfate and cobalt chloride. And for the first year we have done the soil application of it. So you can see the results, what the results are showing to you. The nodule count, you can see we have used cobalt sulfate, and due to cobalt sulfate you can see there was the toxicity effect, or say negative effect of application of the cobalt sulfate to the crop. And you can see the as we have increased the dose of the cobalt sulfate, there was reduction in the nodule count, then nodule weight, urease activity also you can see. On the contrary, you can see in this slide, we have used the cobalt chloride, and due to cobalt chloride, you can see what happened due to cobalt chloride. You can see the nodule count due to due to control, and nodule count due to 100 gram application of the cobalt chloride. You can see here. Afterwards, you can see as we have increased the dose, there was reduction in the nodule count. It means it was again toxic. So cobalt is, you are knowing, it is a heavy element. So we have to use it very delicately. That's why we have tested it, and we came to know that at least 100 gram of cobalt can make the difference. 100 gram. Okay, so let's see what happens in yield. So before yield, I want to show you one interesting thing. We have used cobalt sulfate, and you see what was the 50% flowering time of the normal cultivation of chickpea. It was 57. Okay, and afterwards you can see the time is reduced. It means the cobalt sulfate has increased the senescence in the crop. Whereas in terms of cobalt chloride, you can see here, what you can see, the cobalt chloride has increased the 50% flowering time. Okay, it means it has delayed the senescence in the crop. At the same time, you can see cobalt chloride has increased the crop growing length by at least by 15 days. You can see 106 days, and 121 days in terms of 100 gram of application of the cobalt chloride. It means we are getting extra 15 days due to cobalt chloride application. Okay, and this time it was the soil application. So and afterwards you can see what is happened to the yield. You can see here in terms of cobalt sulfate, the yield was 21.57 quintals, and there was drastic reduction in the yield of the cobalt the chickpea due to cobalt sulfate application. Whereas in terms of cobalt chloride, you can see there was at least 3.5 to 4 quintal increase in the yield of the chickpea. You can see here 21.73 and 25.29 quintals per hectares. So it means if you are giving 15 days extra to chickpea, then it can enhance the yield of the crop by 3.5 to 4 quintals. So, you can see here the yield is increasing. It means the farmers can have extra income through this increased yield. So this was reported for the first time in chickpea that we can apply cobalt at least 50 to 100 grams so that we can increase the chickpea yield. It means we are successful enough through cobalt and in terms of the sudden rise in the temperature at any stage. Later on, what we have done, let's see. So here you can see here. Hello. Hello. Sir, sir, lecture चल रहा है 5 मिनट. So you can see in this picture also and in this slide also the uptake of the content and uptake of the cobalt. So again we were discussing the cobalt is a heavy element. So what is happening in cobalt? You can see here where we have used cobalt chloride, there is increase in the content of the cobalt up to 800 grams. Okay, and there was reduction in the content at 1600 gram. So toxicity might have more increased, and that's why the crop was not able to take cobalt. Another thing is that here in most of the part of India, now we are using the RO water, and RO water is filtering vitamin B12. Okay, so most of the peoples are suffering the B12 deficiency. And what is B12? The source of B12 is cobalt. So it is cobalt through which we can curtail our B12 deficiency problems, because number of peoples are facing these problems nowadays. Now, one thing is that we have talked about the property of the senescence, that cobalt chloride is increasing the senescence, decreasing the senescence. Another thing is that why the crop yield is increasing? The crop yield is increasing due to the cobalt, because cobalt is also helping in nitrogen fixation. How it is helping in nitrogen fixation? Because cobalt, the nitrogen fixation is totally an anaerobic process, and once the process is exposed to oxygen, the process will be hampered, and it is the cobalt who is going to stop the catching the oxygen, because through cobalt, we are able to synthesize leg hemoglobin, and leg hemoglobin is able to capture the oxygen, which is again ultimately helping for the nitrogen fixation. So we are benefiting through cobalt by two ways. First, senescence, delaying the senescence, and second one, it is indirectly helping nitrogen fixation. So you can see the correlation effect of the yield with other parameters. You can see here the it was positively correlating with the nodule count and cobalt the urease activity likewise. Then in another experiment that I have told you that first time we have used the seed soil application. In the second year, we have chosen 4 methods of application of the cobalt. And which were the methods? Seed priming, you can see, seed treatment, soil application, and foliar application. So we have chosen 4 methods, and you can see in the we have just done means observations of the chlorophyll content. You can see the chlorophyll content is increasing in seed priming, where 1 ppm was cobalt was used. Then in terms of seed treatment, 1 gram cobalt seed treatment. Then soil application 85, you can see here, means 50 means first time we had used 50 grams, sorry 100 gram. That's why we had to check the dose, and again we have reduced the dose up to 50 grams here. You can see 50, 100 and 150 years, because first year it was 100 gram. The minimum dose was the 100 grams. Then foliar application 0.01%. So just 0.01% of cobalt, then you can see the chlorophyll content was increased nicely. You can see here. Then the observations regarding nodule count. We have seen the good number of nodules through 50 grams of cobalt. Again, we have refined our dose. First year it was 100, then you can see the 50 gram even. That's why my objective was to reduce the toxicity. If it is creating any toxicity, of course it will not. The 50 gram cobalt can't go for much toxicity at for 1 hectare area. Even the foliar spray of 0.01% is giving good number of nodules. And at the same time, we have calculated the leg hemoglobin content also. So it was 0.51%, sorry, 0.51 and 0.48. So you can see that we have got good leg hemoglobin content. If the leg hemoglobin content is good, it means the nitrogen fixation can be good, because it will catch the oxygen in the anaerobic process, because the process must be anaerobic for nitrogen fixation. And if the nitrogen fixation is good, then we can have good yield of the pulses crops. Again, the days to 50% flowering and days to maturity we have seen, and what we have seen, you can see here that days to 50% flowering are increased in soil application and in foliar application, and also days to maturity. You can see days to maturity in the chickpea 93 is the control, and it is 107 in soil application and 105 in the foliar application. So we can see here that we can comment on 2 methods here: the soil application and foliar application. They can give good results in terms of days to maturity. But we will go to the yield also. So you can see here the yield of the chickpea. There was you can see the 15 to 20% increase in the yield, or more than increase in the yield. You can see in control it has given 22, but we can see it has given up to 27 quintals of the yield. Even it was at par. And the yield was at par with the 1%, 1 ppm cobalt, then 1 gram of cobalt. You can see it means we can go for any method if we want the good yield of the cheap P. So we can minimize the dose of the cobalt through seed priming also. Okay, so seed priming 1 ppm cobalt. So again, the question of toxicity is coming. Then there can't be a question of toxicity because we are using very lesser amount of the cobalt here. You can see. So we can use these methods. So seed priming, then seed treatment, soil application, foliar application for application of the cobalt. Then again, we have thought about why don't other methods can be used. The other method was to employ the biofertilizers along with the cobalt. So we have done and we have worked on that. So I'll come to that. So just see the cobalt content in the seed priming. It was there was reduction in the cobalt content. Then, but due to soil application, there was as we have increased the dose, it is reduced, but it is increased due to seed treatment. Okay. So you can see in this photograph, the control is showing you the senescence, early senescence. Then foliar application, you can see a nice lush green color still, and the pods are in maturity stage. Okay, and the pod filling stage. And here you can see the crop is about to mature here. So this is the difference. Then seed treatment, you can see it is intermediate. Okay, seed treatment. So foliar application was more green. There was more greenness in the foliar application. So you can just imagine the one spray of the foliar spray can make the difference in the senescence time of the chickpea crop. Then with another student in third year, we have used cobalt seed treatment along with the biofertilizer like rhizobium, mycorrhiza, PGPR, then combination of the rhizobium and mycorrhiza, then combination of the rhizobium and PGPR. And let's see what happens to it. You can see here the leg hemoglobin content was good with rhizobium and mycorrhiza. Of course, there must be because rhizobium is helping for nitrogen fixation and mycorrhiza is helping for the solubilizing the nutrients and supplying the water. So that's why you can see the results here, and the results with seed treatment was good with the 1 gram of the seed treatment of the cobalt and 1.5 grams. Then days to 50% flower, you can see the rhizobium plus mycorrhiza can enhance the crop they delay the senescence period. Here you can see, and here you can see 94.69. Again, cobalt has increased the delayed the senescence. Here you can see. Then yield, you can see 1 gram and 1.5 gram cobalt per kg seed are nearly, they are at par. At the same time, rhizobium plus mycorrhiza with the cobalt is giving good result over other biofertilizers, you can see. Then the content of the cobalt, you can see the content of cobalt is increased of course, as the dose were increasing up to 1.5 grams, there was increasing in the content of the cobalt. But you see the property of the mycorrhiza here in solely mycorrhiza and in combination with the rhizobium, the mycorrhiza is able to absorb more and more nutrients. We are knowing about phosphorus, we are knowing about water, but through this experiment, I can say, or we can say that the mycorrhiza is able to absorb good quantity of cobalt also, because we have worked on cobalt, we don't know about other elements. You can see here cobalt is more than sole rhizobium, sole PGPR, and combination of the rhizobium and PGPR. So this is a good study, and we can carry it forward again also, afterwards also. Then with the fourth experiment, with with four students, we have carried again. We have forwarded the experiment with. We have tested three varieties of Kabuli chickpea, and one another finding with the application of chickpea was the crop spread was increased. I forgot to show you that the crop spread was increased. It means the crop is getting means needs more space for the canopy growth. That's why we have used two spacing here. Okay, and so far with the three studies we have used the we had tested 3 to 4 combinations methods. So we have used this time we have used seed priming, seed treatment, and foliar spray. Again, my concern was to reduce the dose, and that's why we have used for on the basis of three studies, we have finalized these treatments, this with three Kabuli chickpea varieties. And let's see what happens to the observations. You can see, since we are talking about climate resilient technology, so just by varietal study you can see we are able to isolate one variety, this variety PKB2, which is giving you delayed senescence by 4 to 5 days. Okay, so we can recommend this variety. Okay, then spacing also not mattered here in terms of this, but normally it was the observation. But we can see in this the yield also, the size of the yield, the or the test weight of the, and this was good. And general observation with the 30 centimeter spacing was that the crop wants more canopy, so that's why we went for the more spacing. Then you can see the foliar spray of 0.01% was good in terms of the Kabuli chickpea varieties. The interaction was also significant, and the PKV2 variety with 45/10 had given good yield. You can see here. Then the interaction with seed was significant here. You can see I was talking about the spacing. So so you can see here the 45/10 because more number of plants were accommodated in this spacing. That's why the yield was good in 45/10, uh, but it was superior over the earlier we had used the 30 centimeter spacing. So that's why we have went for the 45 and 60 spacing. So we can see here means the seed treatment at 1 gram per kg seed or foliar spray at 0.01% can be good in Kabuli chickpea for good returns. Then this was our total finding with the cobalt with 4 experiments, and you can see the results were quite good with number of methods we have used, number of varieties we have used. Okay, so again we can again I have got a new project on the basis of this through DST, and I am working on that with number of nutrients, and cobalt is one of the factor in that. So one student, we have done the work of the RCT. And in that we have resource conservation technology. We have used conventional tillage, means tillage, and the fertilizer application. So we have used 4 methods of fertilizer application: the broadcasting and depth. We have applied the fertilizer at 7 centimeter, 9 centimeter, 11 centimeter depth. Okay. and conventional tillage with conventional plus rice plus straw mulch we have used. So again, in terms of climate resilient technology, we can see we have used this technique of conventional tillage with rice straw, and you can see at least we can say that this technology is able to delay the senescence by a few days at least. Okay, we can talk because we are talking here about the climate resilient technology to enhance the yield of the pulse crops. Then in terms of yield, you can see here the conventional tillage plus rice straw mulch is giving good yield, and at 8 centimeter depth of fertilizer, it is good. Good. So we can go up to that depth also. Okay. Because if you are applying the broadcast method, then there are losses of the fertilizers, and that's why we have to go for the fertilizer sowing, like seed sowing. Then we have tested the soil properties, and you can see due to the soil manipulation, the minimum tillage with rice straw mulch has enhanced the soil organic carbon, and bulk density also the improved due to this method of tillage. Then you can see the porosity of the soil was increased due to the fertilizer sowing at 8 and 11 centimeter. Increased actually at 8 and 11 centimeter. So other things, number of technologies are available, but I have focused especially on whatever studies we have done at Navsari. It was my try to disseminate this knowledge to you also, so that you can also try these technologies to fight with the climate change, at least in relation with the cool season pulses, because as the temperature will increase, there will be increase in decrease in the cool season pulses yield. So thank you very much with this. If you have any queries, you can just raise the questions. Thank you very much.
Is there any query? In the chat box, is there any query? So we don't have any query, and we are getting the feedback regarding your presentation. Your presentation is very nice presentation. Nitin Kurde is my colleague, one of my good friend, and I got this opportunity to say thank you on this platform. Dr. Kurde very nicely covered regarding the meteorological point of view regarding the onset of monsoon, onset of the winter season, how this winter season is playing the very important role regarding the production of the yield, particularly the chickpea and the wheat crop. Very nicely explained. Onset of winter, shift in the season. Could they also discuss about the how the season is shifting and how we can manage our cropping system to getting good yield. And Dr. Nitin also explained very well the simulation model projected result also. As we know, the continuously CO2 level is going to enhance, and our temperature level is continuously rising, and how the future projected climate, what is happening, what will be happening, and what is going the projected yield. Would they also very nicely explain about the experiment of the cobalt application? I have gone through your entire presentation, and I say a very nice experiment you have conducted regarding the cobalt application for the crops, chickpea crops, and you clearly shown that not only the yield you are enhancing, you are also enhancing the vegetative wages to the yield. Over all the development you have studied through your cobalt application, and you also very nicely explained about the biofertilizer application on the chickpea. And I'm also congratulate to you regarding getting a very new project, DST project, cobalt application. So overall, your presentation was very nice presentation. You have nicely covered all the practical point of view, and I'm very thankful for
Thank you, sir.
Giving us time.
Thank you very much, sir.
platform is given to Dr. Tushar Patel for further necessary important things for this webinar.
Thank you, Dr. Nitin Gurdeji, for your nice.
Thank you, doctor.
We are really enjoy and we also gain lots of information and knowledge from your presentations. Okay, dear participants, today we witnessed three eminent speakers, Dr. Y.P. Singh sir, Dr. Anil Dixit sir, Dr. A.R. Jat sir. And these three lectures are really very resourceful and very informative. I hope you all are definitely enlightened with the lectures of these expert speakers. And we have also witnessed two opportunity speakers. One of the speaker is me, and next is my colleague Dr. N.N. Gurde sirs. I think you might have enjoyed both the speakers. For tomorrow, again, we have scheduled the three expert speakers and two opportunistic speakers. First expert speaker is Dr. Shekharappa sir. His topic is on insect pest management in organic farming through micro insecticides. Our second expert speaker is Dr. Lalit Mahatma sir. His topic is on microbes, volunteers of excellence of the managed natural resources in agriculture. Third is Dr. D.M. Jethwa sir. His topic is on role of entomopathogen in insect pest management. And two speakers that are Dr. Brij K2 and Dr. H.H. Patel. His topic is on nutritional interventions to mitigate the methane production in ruminants and enhancing water use efficiency need of an hour respectively. So all the participants are requested to kindly join the sessions sharp at 10 o'clock. And I'm also highly thankful to all the speakers, all the participants to continuous bear with us on today's sessions. I know that this is very much high time for lunch, even though the many participants are still bear with us. So I again thankful to all of you, and have a great day ahead. Thank you so much. We will assemble here for tomorrow session sharp at 10 o'clock. Still, I observed Dr. Y.P. Singh sir. Sir, if you want to share something, the platform, I am able to share the platform with you, sir.
Y.P. Singh sir. Y.P. Singh.
Thank you very much, Dr. Patel Saab. I am highly grateful to you for giving me opportunity to be a part of this your webinar. Very important aspect which you are dealing in this webinar, and it's my great pleasure that one of my colleague Dr. was present at that time when I was delivering my lecture, and he's very learned and my colleague in this field of salinity management. And I'm since yesterday I missed that opportunity to see your presentation and see the deliberation because I was not feeling well. But little bit today I'm little bit fine, so I'm with you, and your I would like to congratulate on that you planned in your program in such a nice way that each and every aspect of natural resource management, which our worthy chief guest was emphasized, that you have touched each and every aspect of natural resource management in your plan. So really it is very wonderful, very important. But one suggestion I would like to give you, if you compile all these things in a document form, then definitely it will be a boom, or it will be worthwhile for the natural resource management field. Because generally I have attended many seminars or many symposium in the natural resource management, but some aspects are just sidelined, that only one aspect is covered mainly, whether it is resource conservation or whether it is reclamation and management, or so. But you covered in a wide perspective. Your seminar really is in a wide perspective. So this is again, I thanks to and congratulate you and your head of department and your vice chancellor, your faculty. Really, they did a very very hard exercise, very big exercise for planning and inviting the speakers. I have seen that you invited very learned speakers in their particular fields. So this is not an easy job. It's very difficult. Although we are having our own academy, we have constituted our own Academy of Natural Resource Management. And last month we also organized a international webinar on this natural resource management. But we have not even covered. I can say straightway that we have not even covered all aspects which you covered in your webinar. So and the speakers you selected really are very wonderful, very energetic and very efficient in their particular respective fields. So once again, I would like to congratulate. And I don't know from where you get my name. I was not known to you, Tushar Patel Saab. I was not very well known to you, but I don't know from where you collect my name and give me opportunity and be a part of your organization. And so once again, I thank you all. Thank you very much.
Dr. D.D. Patel, sir, you want to say something?
Thank you, YP Singh, sir. It's your wisdom, sir, that you have accept our invitation to deliver the lecture, and whatever you are told you on this platform, it enlighten us to do more things for the benefits of the farmers, for the benefits of the students, as well as for the society, sir. So your things are very enlighten us to do more for the society, sir. Thanks a very lot, sir.
Sir, YP Singh, sir, actually we were meet somewhere in Dr. YP Singh, actually we were meet somewhere in a conference at New Delhi, sir. So I know at that time, sir. I know that's why I know what the capability you have, sir. So I just want to invite you, and you are agree with my proposal. So I really appreciate, and thank you so much, sir. And so far you have raised 1 or 2 points regarding the minutes of meetings and compendium, sir. Definitely we have invited the script of the speakers, and it will compile in form of the compendium that will disseminate to the participant as well as the expert speakers, sir. And we have also planned to shortening the minutes of that entire events, and it will submit to university. Eventually it will submit to government also, and definitely they will approach to you also. So we will have some fruitful conclusions from these webinars, definitely, sir. However, I am highly thankful for your word of wisdoms and appreciations that will really build up the confidence of the newcomers like me, sir.
Thank you very much. Thank you, Doctor. Thank you. So nice of you.
Okay. One announcement for participants: kindly participate in the daily quiz that enables to sort out the attendance and your active participation in the webinars. Again, thank you, everybody. We will declare this session is over now. We will meet tomorrow morning sharp at 10 o'clock. Namaskar. Have a great day ahead. And Dr. YP Singh, sir, I pray to God you will get well soon, sir.
Thank you. I am recovering little bit. I am trying to recover. I am taking medicine and all these things. So thank you. So nice of you. Thank you.
Okay, have a great day, everyone.